Welcome to Prelim Preparation 2026. So this is going to be your preparation to this year's trial. Reason why I did this is that I went through the past papers for trial. They're a little bit trickier compared to the normal November paper. So I wanted you guys to be well equipped for your trial, as it contains a lot of marks in terms of like your final mark. So, and also the nice thing is that if you can master this and if you can do well in your trial exam, that means the fact that your November you have less stress. So that is why I decided to do this. So I have a recording schedule, right, or a release schedule on which when each paper is going to be released. So the preparation is going to start now, as you see in this video. So this is the release schedule, right? So it's within each date. So as you can see, the fact that we have June when each paper is going to be released, right? And also we have like July, right? As you can see, July is going to be like double releases because of like it's close to August, because then you have 1 month. And then we have lastly August, which is going to be this, completing the entire trial papers from last year. So this was very important for me to make sure the fact that by the time you guys write your trial exam, all the provinces are covered, right? Welcome to Gauteng paper 2. So as you know, the fact that the video also comes with this video but in a PDF format, but that is only the PDF format of it is only available to people that are part of the membership. So right now what I'm going to do is that I am going to show you a tutorial on how to join the membership and also how to get the PDF. So let's just do that. So first I'm going to show you guys on how to join the membership. Obviously you're going to search my name, then you're going to click on my profile, then you're going to land here, right? Then you have two buttons. You have the subscribe button, right? And you also have the membership button, right? So the join button is where you join the membership. So when you click on it, right, you'll see the fact that this is going to be the membership, right? Then it tells you what you get: membership, only videos, early access, you get it, priorities, and all that, right? So now, do you see the fact that we already have exclusive content, right? So this content is strictly on the membership, right? So now when you say join membership, it's going to load, obviously. Then let me just say yes. Then it's going to load. Then when it loads, do you see the fact that now you're part of the membership, right? So when you scroll down, right, is that you're part of the membership, meaning you have access to all the members, right? So let me just go like this, right? So you can see the fact that you have everything that's related to members, meaning it's from the videos, right, to the most recent post, right? Then also now how to get the PDFs, right? So under members, you're going to see the videos. Then when you go through post, that's when you're going to see my post. You're going to see post of like public, and also when it's written to members only, you now can see it, right? As you see the fact that every time when I release a video, I do say the fact that there's a PDF. So this is the PDF for the NBT past paper, right? And also this is the PDF for the master series, right? Then this is like the normal posts, right? Then do you see the fact that this is the PDF for what? This is the PDF for paper 2, May, June. And also this is the PDF for what? For paper 1, right? Okay, so now let's go to one of the posts, right? We see the fact that this is the access. Now when you click on it, right, it's going to give you like Google Drive, because it's a Google Drive. So don't worry, it's public, right? So then when you scroll down, you'll see the fact that the PDF is within two versions, right? Is that you have the actual, it tells you that which PDF it is, right? Then you're gonna have the question paper first, right? Then after having the question paper, then you're gonna have the memo. The memo is exactly how the video is, but now it's in PDF format, right? So all of them are going to be like this, where you get what? You first get the question paper, right? Then underneath it is the memo. Hope that makes sense, right? So that is how you would get access to this PDF. So now we're going to do statistics. So we're going to do question 1. So it says the histogram below shows the marks of grade 11 learners, right, in their November 2024 exam. So this is the histogram. So we have the histogram. Then the first question, they said the fact that we need to complete this table, right? So we need to fill in the frequency. Then after filling the frequency, we need to fill in the cumulative frequency. So what is the frequency, right? We see the fact that it starts from 10 till 20, right? So our interval is from 10 to 20. So do you see the fact that the blocks are within the interval that are exactly in here? Do you see that? Right? So now we see the fact that frequency is just this numbers. That is our frequency. So we're just going to put those numbers, right? So let's do that. So we see the fact that here it's 2. So this one is going to be 2, right? Then it's 3 here. Then it's 4, right? It's 4, it's 6, it's 5, it's 5, it's 4, so it's 5, so then it's 4. Okay, cool, doesn't want to erase. So then it's 4, then lastly it's 6, right? So what is cumulative frequency? So now let's do cumulative frequency. The first number is going to be the exact one. So it's going to be 2. Then the next one is going to be what? It's going to be this number. So the next one is going to be this one. It's going to be this number plus this one. So this is going to be the same as 2 plus 3, which is going to give me 5. Then the next one is going to be this one plus this. So it's going to be 5 plus 4. Which is going to give me 9. And we're just going to continue like that. Then it's going to be 9 plus 6, which is going to give me what? Which is going to give me 15, right? Then it's going to be 15 plus 5, which is going to give me 20, right? Then it's going to be what? It's going to be 20 plus what? Plus 4, which is going to give me 24. And lastly, it's going to be 24 plus 6, which is going to give me 30. So how do you know you have the right cumulative frequency and frequency? Is that if you add up all of them here, right, the total frequency here is 30, which is going to be the same as the last cumulative frequency. So now we're going to do 1.2. It says what you call this, draw the ogive here, right? So now coming here, right? So the ogive, it's what? It's this, right? And it's this, right? So where does the cumulative frequency go, right? So the cumulative frequency on the ogive comes here, right? And the class marks becomes here. Hope that makes sense, right? So now finding the coordinate, right? I'm just going to do the coordinate and I'm going to do it in red here, right? So the coordinate is going to be this one, right? So it's going to be this 10, right? Needs to match up with this one. So this, right, do you see all the numbers that are here? And maybe let me just do this so that we all see it. So do you see these numbers here, right? Are going to be your, this is your what? This is going to be your x-axis. So this is going to be your x-axis. So this is the x, right? And you see this number, the cumulative frequency, the one that you just found, right? So let me just do this. This. See, this is your y. So go back. So this is your y, right? So now creating the coordinate, right? So for the first one, always for the first one, it's going to be what? It's going to be 10 is to 0, always. Then the second one, right? So then the second one matches up with this one. Hope that makes sense, right? So it's going to be what? It's going to be 20 is to 2. Then it's going to be 30 is to what? Is to 5. Then it's going to be 40 is to what? So it's going to be 40 is 2. So it's going to be, maybe let's just do it like this. Move it up so that it can match up so that you can see. Okay. Let me go back like this. I want to do something. So I want to match it up properly, right? So I said this is the x and y, right? I said this one matches up with 20. So it's going to be 20 is to 2, right? Then 10 always gets 0. So the first one here always gets 0. So that's 10 is to 0. Then this one matches up with 30. So it's going to be 30 is to 5. Then this one matches up with what? This one matches up with 40. Then this is going to match up with 50. Then this one is going to match up with 60. Right? Then this is going to match up with 70. And this one's going to match up with 80. Right? So this 80. So this 80. Right? Gets the last one. Hope that makes sense, right? So now this one is what? It's 9. So this is going to be 9. This one's going to be 15. This one is going to be 20. And this one is going to be 24. So this is one going to be 24. And lastly, this one's going to be 30. Hope that makes sense, right? So now we're going to just plot it here, right? So when we plot it, we know the fact that 10 is to 0. So we know the fact that 10 is to 0 is here, right? Then 20 goes with what? So 20 goes with 2. So we see the fact that, let's check, this is what? This is 0, 1, 2, 3, 4, 5. So meaning 2 is here. So 20 goes with 2, so it's going to be here, right? Then we see that 30 goes with 5. So 30 goes with 5. So 30 goes with 5, so it's going to be here, right? Then 40 goes with 9. 40 goes with 9. So 9 is going to be here. 40 goes with 9. Then we see that 50 goes with 15. So 50 goes with 15. So it's going to be here, right? 50 goes with 15. 60 goes with 20. So 60 goes with 20. So it's going to be here, right? 60 goes with 20. Then 70 goes with 24. So 70 goes with 24. So it's going to be 24. So it's up below here. Then lastly, 80 goes with 30. So 80 goes with 30, which is going to be up here. Then ogive is just connecting it like this. So it's just connecting like this. Maybe let's make it with another. Maybe let's just make it a little bit smaller. Yes. So it's just like this, connecting it like this. So that's going to be your ogive. So we're going to do 1.3, right? So with 1.3, it says use the ogive to determine how many learners obtain at least, right? So let me just highlight the word at least. What does it mean at least? It means students that obtain 50, like at least 50, 54, meaning we're looking for all the students that obtained 54 and upwards, right? So in the exam. So that's very important, the at least. So first we need to determine the student that obtained this 54, right? Then we'll be able to find the at least, right? So let's go to the ogive. So 54, we see the fact that it's here, right? Because of here, the intervals between here and here, it's 2. So this is 2, 4, 6, 8. Then this is going to be 10. So this is going to be 50, 52, 54, 56, 58, and 60. Hope that makes sense, right? So with that, is that now let's just emphasize that. So this is going to be going like this, right? And it's going to just come here. We see the fact that it lands here, right? So we see the fact that it lands here, right? So it lands here. Maybe let me just do it with this line, with this green line, so that you can see it with through a line, right? It lands here. So that's what? If this is 15, 16, 17. So it's 17, right? So we see the fact that 17 student. So we see the fact that 17 students, right, got 15, got, right, which was 17 students, right, got what? Got 54% and below. So from here to here, 17 student got 54 and below, right? So for what you call this, student got 54%, right? So 17 student got 54% and below that, right? And below. So that's the amount of students. But we want everyone that got above it, right? So above it is going to be anything that's up here. So it's that we want at least 54. If you're looking at least 54, this region that we found here, it's everything that's below, right? So we want above, meaning we want from students from 54 and above. So I'm looking for this remaining, how many students that got from here going up. And that's simple. So to find at least 54, it's basically equals to at least 54% is looking at the total student minus the one that got below, which is 17, right? And when you say 30 minus, 30 minus 70, you're going to get your answer as being what? As being 13. So meaning 13 student got what? 54% and above, right? At least, meaning starting from 54 and going up, which is 54 and above. So now we're going to do what? Now we're going to do 1.4. It says it is further given that the minimum mark is 12%, right? So we see the fact that the minimum mark is 12%. So let's highlight that, right? And they tell us the fact that the range of the data is 66%. Then they said the fact they use the box, use the grid, so meaning this, right, to draw your box width diagram. So to draw a box width diagram, you need the following, right? You need your minimum, which we have as being 12%. We need the maximum, right, which we don't have, but we have range. So we know the fact that range, is equals to what? Is equals to our maximum minus the minimum. So we know the fact that the range is 66%, right? Since the range is 66% and we're looking for the maximum and the minimum is 12%. So it's going to be 66% minus 12%. We're going to find that our maximum is going to be what? Our maximum, right, when you punch that into the calculator, we find that our maximum, this is plus, sorry. So we find that our maximum is equals to 78. So it's going to be 78%. That's going to be our maximum. Hope that makes sense, right? So we found that our maximum is going to be 78%. Then we need Q1, Q2, and Q3. So Q1, right, it's going to be what? 50% of the data, right? Then Q1, right? So Q1 is not 50%. Q1 is basically 25% of the data, right? Q2, it's going to be 50% of the data. Then lastly, Q3 is going to be 75% of the data. So now looking at the data, right? So looking at this is that we need to find 50% of 30. Remember that the data is students, right? We have a total of 30 students, right? So 30 students. So we know the fact that we have 30 total learners, right? So what is 30%, right? Also, what is 30 multiplied by what? By 0.25, right? So when we do that, if you say 30, finding Q1, right? So we see the fact that it's going to be what? So if you say 30, right, multiplied by what? Multiplied by 0.25, which is 25, we get the fact that we're going to get 7.5. So we're going to go to the cumulative, which is here. Remember the fact that we want the percentage. So we're going to look for 7.5, right? So this is for Q1. So if we look for 7, so this is for Q1. So let me just say Q1, right? So 7.5 is where? 7.5 is here, So we know the fact that this is 6, this is 7. So 7.5 is somewhere here, right? So this is 7.5. So you're going to draw a line through that. So 7.5, you're going to draw a line going through. So it's going to be, let's make it blue. So a line going through, touching here, right? Then it's going to touch here, right? So that's what we're going to have, right? So we see the fact that Q1 is here. So Q1 is here, right? It's here. And if we read it up, we see the fact that this is going to be what? If this is 30, 32, 33, and this is going to be 38. So this is going to be 30, what you call this? If this is 2, 4, 6, 36. So this is going to be 36. So 36% is going to be Q1, right? So this is going to be Q1, right? Then now we're going to be looking for Q2, right? So Q2 is going to be what? It's going to be 30 multiplied by 50%, 0.5, and that's going to give me what? That's going to give me 15. So we're going to go back here and look for Q2. All right, 15 is here, so we're going to just hit it up here, just like that. And we see the fact that Q2 is going to be this one, right? And this is going to be Q2, right? Which is going to be equals to what? This is going to be equals to 50%, right? Then lastly, we're going to be looking for what? We're going to be looking for Q3. And Q3 is going to be 30 multiplied by what? 30 multiplied by 0.75, right? So if you say 30 multiplied by 0.5, so if you say 30 multiplied by 75, right? Then we find the fact that it's going to be 22,5, right? So 22,5 needs to be somewhere here. So this is going to be 21. This is 21, this is 22, then 22,5 is going to be somewhere here. So it's going to be somewhere here, right? So we're going to draw a line there. Right? And we're going to go. So it's going to draw a line here. Let me just draw it properly. It touches here. Then from here, it goes down like this. And we see the fact that that is going to be Q1. This is going to be Q3. And Q3, this is what? This is 2, 4, 6. That's going to be 66. So now drawing the box with, right, is that we know the fact that the minimum is what? Is 12. So we're going to draw lines there. So 12 is there. So it's going to be, let's check what's the interval. This is 1, 2, 3, 4. So it's 5. So it's 2. So this is going to be our 12. So we see the fact that this is going to be our 12, right? So this is going to be our 12. So a line going like this, right? And we see that our maximum is 78. So 78 is going to be somewhere here, just like that, right? So that's going to be our minimum and maximum. So this is going to be minimum, and this is going to be our maximum, right? Then now we need to find Q1, Q2, and Q3. So we see the fact that Q1 is 36. So 36 is what? It's where? 2, 4, 6. So 36 is here. So we see the fact that 36 is going to be this box here. So let me just... It's going to be this box here. So just going here like this, right? It's going to be there. Then 30... That's 30. 36 is somewhere here. So let me just go like this. Somewhere 36. 36. Okay, cool. This is 2, 4, 6. So 36 is here. Needs to be here. Let me just draw. I'll just draw them in dotted lines. Then I'll just make them solid. So 36. This is 2, 4, 6. So 36 needs to be somewhere here. That's Q1, right? Q2 is 50, so Q2 is 50, right? then 66, so it's going to be 246. So 66 is going to be here, right? So that is going to be Q1, Q2, and Q3. So this is going to be back to solid, Q1, Q2, and this is going to be Q3, right? So now I'm going to draw the box. So drawing the box, we know the fact that the box connects Q1, Q2, and Q3 just like this. So just like this. Okay, cool. So it's going to be from here to here. Yes, then connect this box just like that, right? Then you connect the lines like this, right? So this is how you will draw your box inverse diagram. So now we're going to do question 2, right? It says a town manager conducts a survey to measure the pressure of sea levels, right, in the coastal city. Then the table shows a scatter plot, right? So it shows us like the results first, and it shows us like a scatter plot. So they already did the scatter plot, right? Then the first 2 questions, which I'm going to do number 2 after this, is that it says determine the equation of the least squared regression line and determine R. So both those questions you need to use the calculator. So that's why I'm doing it. I'm gonna reference my master statistic video so that you can see how to use the calculator and how to find this. But here is the answer. So for 2.1.1 is that your A value, so the A value after using your calculator, you're going to get as being 55,96, right? And you're going to get that your B value is going to be equals to 22, right? 81, right? Therefore, your equation, you know the fact that is y is equals to what? Is equals to 55, right? 55,96, right? Plus 22, 81x. So just in red, right? We know the fact that the equation is y is equals to what? Is equals to a plus bx. So this is the equation that you need to use, right? Then your A and B, you're going to get it using your calculator. Then your R, also using your calculator, is that your R is going to be equals to what? In this case, it's going to be 0.96. So that's how you will find your A and R. Hope that makes sense, alright? So as I said, the fact that I'll reference my master statistic video so that you can see on how to find your A, B, and C. So now what we're going to do is that we're going to do 2.1.2. It says use the scatter plot provided below to draw the least square regression line, right? So using this is that you need 2 points, right? So the first point is that this is the one that you're going to get from your equation. Remember the fact that you got your equation as y. And let me just put it down because I'm going to need the space here. So we got it as y is equals to what? Remember, it's going to be y is equals to 55, right? 96 plus 22, 81, right? X. So this is a linear function, right? If you rearrange it properly, this is the same as y is equals to 22, 81 x plus 55, 96, right? Where this is the gradient, so where this is the gradient and this is C, right? So we know the fact that this is M and this is C. So if this is C, we see the fact that we know the fact that C gives us what? Gives us the y-intercept, right? So C gives us the y-intercept, meaning the coordinate for the y-intercept is 0 is 255,96, which is roughly the same as like 0 is 256. So that's my first point, right? So here, drawing the least regression is that we're going to be looking for 56, right? So here, let's zoom it in. We see from 0 to 100, we have 1, 2, 3, 4, right? So meaning it's 5. It's a difference of 5, right? So if it's a difference of 5, meaning this is going to be what? This is going to be 10. This is 10, 20. This is going to be 20, 40, 60, 80, then 100, right? And we're looking for what? 54, right? So if this is 10 and if this is 20, right? And this is 2, 4. So 20, this is 40, and this is 60, right? So meaning what we're looking for is somewhere where? It's somewhere here. So where is it? Okay, red. If this is 2, 4, and 6, right? So meaning this is 60. So we're looking for 1, 2, somewhere here. So it's going to be somewhere here. It needs to be somewhere here. Our x-intercept is somewhere, our y-intercept is somewhere there, right? So that is going to be the first point that we're going to focus on. Then the second point, right, is going to be your mean. So it's going to be your average. So here we're going to look for the average, right? So we're going to look for the average of the x. So we're going to be looking for x bar here, right? And also we're going to be looking for y bar, right? So x bar is adding up all of them, right? When you add up all of them, right, what are you going to get? It's going to be add up all of them. So it's going to be 5 plus 8 plus 12, all of them till 29, divided by the number of them. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So divided by the total. So it's going to be 5. This is the same as 5 plus 8 plus, then I'm just going to continue till 29. Divided by what? Divided by 10, right? And that you're going to get as being what? As being equals to 17, 8, right? Then the y bar is going to be everything here divided by the total. So it's going to be what? It's going to be 210 plus 290. Then you continue till 780, right? All of them. And that is going to be divided by what? That's going to be divided by 10. And you're going to find that your y bar is equals to 462. So your other point here is going to be what? It's going to be 17. Is 17,8 is to 462. So this is the same as 18 is to 46,2. So let's go plot it in here, right? So we're looking for when we have x is equals to what? Is equals to 18. So 18 needs to be at the bottom. So the depth is going to be 18. So it's going to be 18. So let's see. 1, 2, 3, 4, 5. And from here it's going to be 15, 16, 17, 18, 19, 20. So we know the fact that it's intervals of 1. So we're looking for when it's like 18. Yeah. So 18 here is going to be 16, 17, 18. So 18 is going to be here. So we know the fact that 18 is going to be somewhere here, right? Then we're looking for when it's 464. So 62, right? It says 62. So we know the fact that it's 462. And here's intervals of 2, 10. So this is going to be 62. So it's going to be 60 round there, right? So this is going to be what? This is going to be 2, 4, right? 6. So it's somewhere here. So it's somewhere here. So it's going to be somewhere here, right? Then we're basically going to just like connect those two, right? So I'm just going to connect the two so I can see roughly where it is. I'm going to erase it, right? So I'm going to go like this. And I'm going to go somewhere like this, right? So it's going to be the point where is the x bar and y bar is somewhere here, right? It's somewhere there. Then I'm going to just erase this. So our line needs to go from where? Needs to go from here and connect to there, then extend. So let's do that, right? So our line needs to cut through those 2 red points. So doing that is going to go from here till, okay, go. So let me just, this is too thick. Yeah, so our line goes like this. Regression line. Then it needs to pass through. Do you see? So do you see the fact that that is the regression line? So that's going to be our regression line. Hope that makes sense, right? So it passes through this point, and this point here is what? It's going to be 17,8. So 17,8 is to what? Is to 462. So that is that, right? So that's how you would draw the regression line. Remember the fact that you need the y-intercept, which is going to be always given by this, right? And lastly, you need your average of your x bar and y bar. So now we're going to do 2.2, right? So it says a research was conducted to measure the testosterone level in runners at the Olympics Games. Then they tell us that the table below shows the results of five runners who were tested for the hormone, right? Then they tell us the fact that this is the table. Then they tell us more important information, that the 5 runners, mean of the 5 runners is equals to 7.7. And they tell us the fact that the value, right, of the last 3 form an arithmetic sequence, right? So now we need to determine P and K, right? So we know the fact that the value of this one forms an arithmetic, right? Forms an arithmetic sequence. So we know the fact that P, so let's do this. The arithmetic sequence, so I'm going to say the arithmetic. Let me just increase my pen. Yes. So the arithmetic, right? The arithmetic sequence is what? It's P is 3,8 and it's 4,3, right? So this forms an arithmetic sequence. What do we know about an arithmetic sequence? Is that their difference is equals to each other. So if we find the difference between these two, right, it's going to be equals to the difference between those two. So this, both of them is equals to D, right? So now let's find that, right? So this is the same as saying 4,3 minus 3,8, because we always start from the back, subtract by the one that's in front. That is going to be basically equals to this and this, right? So it's going to be 3,8, right, minus P. So from here we can solve for P, right? So from here we can solve for P. So we know the fact that this is going to be 4,3 minus 3,8. Then take this one to the other side. So it's going to be 3,8 is equals to negative P, right? So we see the fact that here, when we punch this into the calculator, we're going to get negative 3,3 is equals to what? Is equals to negative P, right? Therefore, we know that P is equals to 3,3. So we have solved what P is from the given information, right? So now solving for what? Solving for K. So to solve for K, they gave us more information. They told us the fact that the average of this whole thing, right, is equals to 7.75, right? So we know how to find average. We know that average, or the mean, is equals to what? Is equals to all the values, meaning it's going to be, in our case, it's going to be 6,7, because we need to add up each term, right? So add up this, divided by the total, which is 5, right? So it's going to be 6,7 plus, then it's going to be 2K plus 2,4, right? Then plus P, but P we know the fact that is 3,3, right? Plus 4.8 plus 3.8, so it's going to be 3.8, right? Then lastly, plus 4.3, right? We know the fact that that is going to be divided by what? That is going to be divided by, that's going to be divided by 5. Because remember the fact that even if not going up, this is 1 and this is one thing, so it's 2, 3, 4, 5 divided by the total, right? So, but we know the fact that our mean is given to be 7.7, so this is going to be 7.7 is equals to 6, 7 plus 2k, right? Plus 1 plus 2.4 plus 3.3, right? Then this is going to be plus 3.8 plus 4.3. And this whole thing is going to be divided by 5. So divided by 5. So taking the 5 to the other side, it's going to be 7.7 multiplied by 5 is equals to, it's going to be equals to what? So I'm going to group every number. So I'm going to add all the numbers together, leaving this one. So when I add all the numbers, right, I'm going to find the following. So adding all the numbers, I'm going to get 20, right, 5 plus 2k, right? Then the 7.7 multiplied by 5, it's going to give me 38, 5 is equals to 20,5 plus 2k, right? Take the 20,5 to the other side, so it's going to be 38,5 minus 20,5 is equals to k, right? Plus 2k, sorry, plus 2k. Let's go up, right? So now when you say 20, when you say 38,5 minus 20,5, right, you're going to get what? You're going to get 18. So this is going to be 18 is equals to 2k. So it's going to be 18 divided by 2 is equals to k. So therefore, our k is basically equals to 9. So our k is going to be equals to 9 and our p is going to be equals to 3.3. So now we're going to do analytical geometry. So with analytical geometry, we're going to do question 3. It says, in the diagram, triangle ABO, right, is drawn, and they tell us the fact that E is the midpoint on this line, right? So we know the fact that this is a midpoint. So what do we know about midpoint is that this and this means that they equal, right? And they tell us the fact that it extends to produce C. Then A is the x-intercept, as we can see in the diagram, and C is the y-intercept, which is this coordinate, right? They give us what C is. Then it continues and says the fact that is the y-intercept on the line AC, what you call this AC, so this line, right? This is the y-intercept. Then they tell us the fact that the line EF is drawn parallel to the x-axis. So this line is parallel to this. So what do we know before even we go further, right? Since we have a triangle, so we see the fact that we have a triangle. So this is the triangle that we have. And they tell us the fact that this is the midpoint. And they also tell us the fact that this is parallel lines. This is midpoint theorem, right? Meaning the fact that we can conclude the following. We can conclude that those two sides are also equals to each other, because that's a midpoint theorem, right? Hope that makes sense. Then it says the fact that the line EF is parallel to the x-axis, and they tell us the fact that AB is perpendicular to OB. So this is 90 degrees. And they tell us the fact that the angle of inclination, right, on what you call this, what are the angle of inclination on OB? So this line, right, is equals to this. So this, right, meaning with this, we can find the tangent of this line. Then they tell us the fact that the angle, it's what you call the angle formed by AC. So the angle that's formed by AC, so it's going to be AC, right, on what you call this, the angle formed by AC, and the y-axis is this theta, this alpha, right? So the first question says what? It says determine the gradient of OB. So we need to determine the gradient of this. So we're going to use this, So we're going to use the one that you have an angle, right, and the gradient. So we're going to use this formula, which is 10 what? I'm going to call it 10 theta, right, is equals to the gradient. So the gradient of what? Of OB in our case, right? So we know the fact that the angle is 108. So you're going to say 10, and the angle here is going to be 108, right, comma 43, right, is equals to the gradient OB, right? So now what we're going to do is that we're going to punch this into the calculator. So when you punch that into the calculator, you're going to get that the gradient is going to be equals to what? Our gradient for this one is going to be equals to 3. It's equals to -3, right? So when you punch that into the calculator, this is going to be -3. So therefore, the gradient of OB is equals to -3. So therefore, the gradient of OB is equals to -3, right? Because remember the fact that this gives us this. Hope that makes sense. So using this is that we can find the gradient of this line that it touches. Hope that makes sense, right? So we're going to do 3.1. It says we need to find the gradient of OB. So OB is this line, right? So we need to find the gradient of that line. So what we're going to use this angle here, right? This angle that they gave us to basically find that, because the relationship between the two is using this formula, so which is going to be 10 theta is equals to the gradient of OB, right? So the line that it touches is that, so the angle here is going to be 108,43 is equals to OB, right? The gradient of OB. So therefore, if you punch this into the calculator, you're going to get -3, right? It's going to be the gradient of OB. So therefore, to conclude, the gradient of OB is basically equals to -3. And that's how you would answer this question. So now we're going to do 3.2. So it says what? It says determine the equation of AP. So let's find AP. So we're looking for the equation of AP, right? Right, in the form of y is equals to what? To mx plus c. So we see the following, right? First, we see the fact that they gave us this equation has the y-intercept, right? So let me just do it in red. So we see the fact that it has the y-intercept, and we see the fact that it's at that, meaning this 10 is basically equals to, the c is equals to 10 because of c gives us the y-intercept from mx plus c. Hope that makes sense, right? So meaning c is equals to 10 from that. Then now what we need to find is the gradient. But what do we see? We see the following, right? We see the fact that the line O, or what you call this, the line OB is perpendicular to this line, right? It's perpendicular to this line. So meaning we already have the gradient of what? Of OB. We can find the gradient of AB. Hope that makes sense, right? So we know the following. We know the fact that AB, right? AB is perpendicular to what? It's perpendicular to OB, right? So meaning that the gradient, right? Meaning that the gradients, when you multiply them together, so the gradient of AB, right, multiplied by the gradient of OB needs to give you -1. We already know what's the gradient of OB, right? So we know that the gradient of AB, what we're looking for, multiplied by -3 is equals to -1. So therefore, the gradient of AB is equals to what? Is equals to 1/3, right? Because it's going to become positive when you divide. So therefore, we know the fact that y is equals to mx. So it's MAP x plus c. So we know that the gradient is what? It's 1/3. So it's going to be 1/3 x. And we know the fact that c is 10. So this is going to be 10. So now we're going to do 3.3. It says calculate the coordinate of B. Where is B? B is here. What do we see B is? B is the intersection between the line BO and the line AB, right? So we already have the equation of this one. We already found this one as being y is equals to 1/3 x plus 10. We already solved that one, right? And now let's find the equation of this one. And it's simple. Do you see the fact that it passes through the origin, right? So it passes through the origin. This is also, it's what? This origin is the x-intercept and also is the y-intercept. So if it's the y-intercept, we know the fact that by default, c is equals to 0, right? And we already have the gradient. So we have the gradient for that line as being the gradient of OB as being -3, right? Because that was the first thing that we solved. So we know the fact that here y is equals to -3x, right? Because plus 0 is just -3x. So since we know the fact that the two intersection, what it is, to find b, we just need to equate them together. So finding b is just saying what? Is saying this equals to this. And solving for x, then solving for y. Hope that makes sense, right? So b is the intersection of, and I'm gonna call it 1 and 2. Or no, let's call it the equation of AB. So this is OB and this is AB, right? So that we can see the intersection of the line Y OB, right? And the intersection and the line, and let me just say and y AB. So what we're looking for, y OB is equals to y AB. So let's substitute. Y OB is -3, x is equals to AB is going to be 1/3 x plus 10. So we're trying to solve for x, right? So we're going to take everything with x to one side and everything with the number to the other side, right? So that's what we're going to do. So when we do that, what we're going to have is going to be -3x, right? And this is going to be what? This is going to be minus 1/3 x, and this is going to be equals to 10. So in your calculator, when you say -3, right, minus 1/3, right, you're going to get that this is going to be -10, right, divided by 3. X is equals to 10, right? So now what we're going to do is that we're going to take the 3 to the other side. Since it's dividing, when it goes to the other side, it's going to multiply. So it's going to be -t, and -10x is equals to 10 multiplied by 3, right? So let's go up, right? So this is going to leave me with what? -10. X is equals to 30. So therefore, x is going to be equals to 30 divided by -10, right? So therefore, x is basically equals to -3, right? So we're going to have our x as being equals to -3. Then this x is going to be, this is our x what? This is our x b, right? So we're going to substitute xb where in either the equation, we can substitute it here, we can substitute it here. So I'm going to substitute it here, right? So I'm going to substitute x equals to -3 into y OB, which is equals to -3x. So it's going to be what? Y, right? Y is basically going to be equals to -3, open bracket, -3. So therefore, y is going to be equals to +9, right? So therefore, this is what? This is YB, right? So therefore, our B is basically equals to -3 is to +9. So that's how you'll find the coordinate of B. So now we're going to do 3.4. It says calculate the length of BF. So we're going to just highlight what we need to calculate. So we need to calculate this length, right? But what is the nice thing, right, is that remember the fact that with the midpoint theorem, after them giving this and this, we have concluded the fact that this is like using midpoint theorem, right? So with that is that we can find what? We can find the length of BO, right? And BF is half of BO. And this is nice because of O, it's 0, 0, the coordinate. So we know the fact that BO, so we know the fact that BO, so we know that BO, right, is equals to what? Is equals to, oh, first, let's do this. We know the fact that BF, right, is equals to FO, right? And I'm going to say midpoint theorem. We know that, right? So with that said, is that we know the fact that BO, which is what? The one that we're going to find, right, is basically equals to BF plus FO, which is the same as BO is equals to BF plus another BF, right, which is BO is equals to 2BF, right? So now making BF the subject is the same as BO divided by 2 is equals to BF, right? So that's why we're going to find what? We're going to find BO. So finding BO, right? So we know the fact that the coordinate of B is -3 is to 0 and O is 0 is to 0, right? So BO is basically equals to the square root of XB minus XO, O squared plus YB, right, minus YO, O squared, right? So we know that, right? So with that said, is that BO is basically equals to the square root of XO is -3 minus 0, right, O squared plus, this is going to be, why did I say this is 9, not 0? So this is 9, sorry about that, right? So that's going to be 9 minus 0, O squared, right? So now, cleaning it up, this is the same as having BO is equals to the square root of -3 O squared plus 9 O squared, right? So now, punching that into your calculator, right? Punching that whole thing into your calculator, we find the fact that BO is equals to what? Is equals to 3 root 10. So let me just fix this, right? But remember the fact that we're looking for BF, right? Therefore, BF, what we're looking for, right, is equals to what? Is equals to BO divided by 2, right? So this is going to be BF is equals to 3 root 10 divided by 2. And that's your final answer on how to find BF. So now we're going to do 3.5. So 3.5 says we need to calculate the area of triangle C. So we see C is here, right? CB. So it's going to be CBO. So this triangle. So this is the triangle that we need to find the area of, right? So finding the area of the triangle, we see the fact that this triangle is 90 degrees, right? So it's a right angle triangle. So meaning height is going to be this one, the one from here going here, creating a 90 degrees. That's going to be your height, right? Then your base is going to be this one, right? So area of that triangle. So area, we know that area of a triangle, right, is basically equals to what? To half base times height, right? But area of this triangle, which is area of triangle CBO, and let me just put this inside here, right? That's the formula of the area. It's equals to what? It's equals to half. What is our base? Our base is going to be a BO multiplied by our height. Our height is going to be BC. So we have BO, right? We know that BO is basically equals to, we have calculated, is 3 root 10. So now we need to calculate BC, right? So calculating BC. So BC, we know the fact that's going to be the square root of XB, right, minus XC, all squared plus, then it's going to be Y b minus yc all squared, right? Then with that is that let's substitute, right? So we know the fact that bc is equals to the square root of -3. Then it's going to be what? It's going to be 0 minus 0 all squared plus, then it's going to be 9 minus 10 all squared, right? So now we're going to have bc being equals to what? To the square root of, this is going to be -3 all squared, and this is going to be plus 9 minus 10 is going to be -1 all squared, right? So let me just do this, clean this up. Yes. So therefore, we know the fact that this is going to give me what? BC is going to be equals to, this is going to give me 9, right? And this is going to give me 1. So BC is basically square root of 10, right? So now let's substitute, right? So we know the fact that the area of triangle CBO is equals to a half, right? And it's going to be what? It's going to be BO, which is going to be 3 root 10, right? And it's going to be root 10, right? So that's the area of that. Then now let's simplify it, right? So simplifying it is that putting it into your calculator, you're going to find that the area, when you punch this into the calculator, this is going to give you what? This is going to give you 15. So the area is going to be 15 units squared. Units squared. So now it says determine the size of alpha, right? So I've used this triangle because we're going to use it, right? So we know the following. We know the fact that we have 90 degrees. If we find this angle, right, this is going to be sum of angles in the triangle. We're going to get this angle. And we know that this angle is vertically opposite with this one. So I'm going to find that. So that's what I'm going to do. And it's easy to find this angle because do you see the fact that this angle is just going to be what? Is this small angle plus 90. And we already know what this entire angle is, right? So to get this is basically what? It's going to be this whole angle minus this 90 degrees. Hope that makes sense. It's going to be this whole angle minus this 90 degrees. So to find that angle, so let's name it, right? So we need to first find that angle. So we know the fact that angle BO, right? BOC is equals to what? Is equals to 108,43, right? Minus 90 degrees, right? So when you say that, right, when you say 108 minus 90 degrees, you're going to get that angle as being what? As being 18,43 degrees, right? So this angle here, do you see this angle here? That's going to be 18,43, right? Then we already know that this is 90, this is 90, this is 90, and we have this. So using sum of angles in a triangle, we can find this, right? So you're going to say what? Angle B. So let's add them out. So we're looking for angle, that angle C, right? So I'm going to start with that. So it's going to be B, right? So BC, so BC O, right, plus this angle that's at the bottom, which is angle BOC, plus this angle here, right? So it's going to be OBC, right, is equals to 180 degrees, right? And the sum of angles in a triangle. So let me just put it. Sum of angles in a triangle, right? So now we're looking for this one, which is BCO, right? And we have this one, which is going to be 18,43. Then lastly, we have that one, which is 90 degrees, is equals to 180 degrees. So angle BCO is equals to 180 degrees minus 90 degrees minus 18, minus 18,43, right? So when you do that, is that you're going to get the fact that that angle, right? That angle is going to be equals to what? So the angle BCO, right, is going to be equals to what? It's going to be equals to 71,57, right? But we're not done. We know the fact that, therefore, we know the fact that angle BCO is equals to alpha, and the reason is vertically opposite angle. So it's vertically opposite angle, right? See, vertically opposite angles. This and this are equal, right? So therefore, our angle alpha is basically equals to 71,57 degrees. So that's how you will find alpha. Hope that makes sense, Anna. So now we're going to do question 4, right? It says in the diagram, P is a center of the circle passing through B, right? Passing through B, T, and the origin. So we see the fact that it passes through here and here, right? And the origin and T, right? Then they tell us the fact that a second circle, right, is drawn with the center Q, which is this one, right? And the equation of that circle is this one, right? And they tell us that the point R, right, and point S lies on that circle. So as we can see here, then they tell us the fact that AS and AR are both tangent to the circle. So we see the fact that both of them are tangent to the circle of the smaller one, which is this one, the center, what you call with the center Q. And they tell us that B is the x-intercept, right? So B is the x-intercept of AS. So we see that, right? So now doing the first question, right? They say determine the equation of P. We see the fact that we have the center, but we do not have R. But to get R, they told us one important information. Do you see the fact that I don't even need to go up. You see the fact that this circle, right? The circle passes through B, right? But the part that is very important, it passes also through the origin, right? And T. So that's what we care. The fact that it passes through origin is that we can we can draw a line from the origin going to P, which is the center, right? And since we can do this, this creates like a right angle triangle, right? So it creates a right angle triangle. Remember when we were doing analytical, trig, right? Since it creates a right angle triangle, meaning this represents what? Represents this side, right? No, this one. I meant that this one represents the x-axis and this represents the y-axis, so we can find R. And what is R? R is the R is the radius. Hope that makes sense, right? So filling it up, we see the fact that here we're going to have -3 and here we're going to have 4. So +4. So we're going to have 4. Let me just see, my pen looks very, okay, cool. Yes, so that's what we're going to have, right? So with having that, we know the fact that using this formula, which is, let me go back to black, finding R squared, right, is equals to x squared plus y squared. The reason why we can use this is because the circle passes through the origin. And maybe let me put it, right? Reason why we can use this formula, we can use this is because of its passing through the origin. Is because the circle is passing through the origin. Hope that makes sense, right? That's the reason why we can use this formula, right? So let me put this inside a block. It's like keynote. So let's just do this. So now using that formula, right? So we know the fact that we're going to have R squared is equals to x squared plus y squared, right? So we know the fact that we're looking for r squared, and x is going to be -3 all squared plus 4 squared. So r squared is going to be equals to 9 plus 16. So therefore, r squared is equals to 25, right? R is always positive, so square root both sides, right? So therefore, r is equals to 5. So we see the fact that our radius is 5. So now, since we know that our radius is 5, using equation of equation of a circle, is the following, right? It's going to be x minus, so it's x minus a, so x plus a squared plus y plus b squared is equals to r, right? Is equals to r squared, right? So that's the equation of what? Equation of a circle. So we know the fact that this is a, and this is b, right? So here, let me just go up. So here, a is going to be opposite the sign of this. So since this is negative, our a is basically equals to +3. Then here, since it's positive, our b is basically equals to -4. So let's substitute, right? So with that said, we know the fact that x plus 3 all squared plus, then it's going to be y minus 4, and it's equal all squared, and it's equals to 5 squared. So now it's going to be x plus 3 all squared plus y minus 4 all squared is equals to 25. And that's how you find the equation. Very important, right? Is that when you're dealing with the equation of a circle, your a and b from what you have plotted is opposite the side. Hope that makes sense, Anna. So now let's do 4.2. It tells us the fact that OT is the diameter of the circle with center P. Then we need to determine the coordinate of T. So now we're going to draw that that OT, right? So O is here. Then we know the fact that our line passes through and like this. Hate that. So it's like this. Right? So let me just fix it. It passes through like this, right? And that's angle T. Point T, right? So point T is just here. Hope that makes sense, right? So now what do we know? We know the fact that this is 0 is to 0. We have that point P. And what do we know about the relationship between these two, right? Is that we know the fact that this is the radius, this upward radius, meaning these two are equals to each other. Meaning point P is the midpoint, right? So what do we know? We know that point P, so we know that point P is the midpoint. So since point P is the midpoint, is that we're going to use the midpoint theorem to find point T because of that's the only one that's missing, right? So using the midpoint theorem, right? Using the midpoint formula. Sorry, using the midpoint formula. It's the midpoint formula, right? We're going to find point P. We are going to find point T, right? Point T. And it makes sense because of, do you see the fact that it's the only one that doesn't have the coordinate? So we're going to call point T, what? We're going to call it XT and YT. So now using the formula, we know that the midpoint formula is midpoint. It's basically equals to what? To X. Remember the fact that we're finding the midpoint of what? Of this. So midpoint of the line, we're going to name it OT. Right? So midpoint of OT is going to be O plus XT right? And that's divided by what? That's divided by 2 is to what? Is to YO plus YT divided by 2, right? So now we already know what? Let's substitute everything we know. We already know that the midpoint of this one is P, right? We know the fact that the midpoint of this one is P, so we know the fact that P, but let me just write it. But we know that the midpoint of OT is basically equals to P, right? So with that is that let's substitute. That is going to be the same as -3 is to 4, right? Is equals to what? Let's substitute the coordinate for O. So it's going to be what? It's going to be O. It's going to be 0, sorry. 0 plus xt. It's divided by 2. Then it's going to be what? It's going to be 0 plus yt. So it's going to be yt divided by 2, right? So now let's clean it up before we simplify it. So it's going to be -3 is to 4 is equals to what? Is equals to xt divided by 2, and it's going to be yt divided by 2, right? So now knowing that is that, remember the fact that this and this are going to be equals to each other, because that's what we're solving. So this and this are going to be equals to each other, and this are going to be equals to each other. So xt divided by 2 is the same as equals to -3, right? And yt divided by 2 is the same as 4. So now let's solve for the x coordinate and the y coordinate, right? So this is going to be xt is equals to -3 multiplied by 2. So therefore xt is equals to -6, right? Then here we're going to have yt is equals to 4 multiplied by 2. Therefore yt is equals to 8. So now the coordinate of t is basically equals to -6 is to 8. So now we're going to do 4.3. It says calculate the coordinate of q. We know the fact that we were given this as being what? As being the equation for q. So our goal is to write our coordinate, our equation in this form, because of it's going to be the coordinate of q is going to be just those two numbers, right? So goal, right? So let me just say goal is to write the equation, write the circle equation in this form, and the form that we want is going to be x plus a all squared plus y plus b all squared is equals to what? Is equals to r squared, because the center in this case is what? Is -a and -b, because it's always opposite the sign, right? Because it's here, it's positive b, so it's going to be negative. Hope that makes sense, right? So that's what we want. So let me just put this inside the block. So to do that, if you have it in this form and you want to write it in this form, you need to do completing the square. So I'm just going to rewrite it again. So it's going to be x squared minus 12x plus y squared plus 12y plus 54 is equals to 0. So the first step that you need to do is that you need to group everything with x together and everything with y together, and the number without x and y to the other side. So we see the fact that we can do that. So grouping them, so these two have to be together, and this two, and this goes this side. So let's do that. So it's going to be x squared minus 12x. Then this is going to be plus y squared plus y, 12y is equals to -54, right? Then the next step is that you need to check the coefficient of your x. We're going to start with x, and maybe let's color coordinate this, right? Let's color coordinate this, right? Just want to increase my, so this is going to be the green one, right? And this is going to be the blue one, right? So dealing with the green one, right? When doing that is that we need to make sure that the coefficient of the coefficient of x is what? We need to make sure the fact that the coefficient of x is 1 and positive 1, right? And we see that's that. Then what we're going to need to do is that we need to take the coefficient of x, right? And basically what you call this, half it, then square root it. So that's what we're going to do. So taking the coefficient of x is that is 12, right? So it's going to be negative. So it's going to be a half multiplied by negative 12, right? And what you get, a half is equals to negative 12. You're going to get negative 6, right? So take negative 6 and we're going to do what? Square root it. Do not simplify it, just leave it like this. And that I'm going to highlight it in green, right? Because that matches up with that. So I'm going to highlight it in green. Hope that makes sense, right? Then now we're going to go to the one with the y. We need to make sure the fact that the coefficient of y squared is positive 1. And we see that's that. Then we're going to do the same thing here. We're going to have the one with the coefficient of y, right? Then we're going to square root it. So let's do that. So it's going to be a half, right? Of what? Of 12, right? Then we know the fact that that's going to give me positive 6, right? So it's going to give me positive 6. Then we're going to square root it. You do not simplify it. Leave it like that. You'll see the fact that why I said leave it like that, right? So now going back, we're going to basically enter them here, right? So here is that we have x squared. So we have x squared, right? Minus 12, right? Then we're going to say plus this negative 6, right? All squared. So let me just put this inside a square bracket. So this is for the green part, right? So this we substitute to the green part, which makes sense, right? So maybe let me just show you the fact that we substituted to the green part, right? So we substitute the green part. Then now what you do to one side, you need to do to the other part. So I'll just show you. Let me just complete writing it. So this is going to be plus now y squared plus 12y. That's going to be plus 6 all squared. So square bracket again with this one. Right? And that is the blue part. So that is the blue part, right? So now we've added this to here, right? So now we need to add it to the other side, because what you do to the left hand side, you need to do to the right hand side, right? So this is going to be minus 54, right? And this is going to be plus negative 6 all squared, plus then it's going to be positive 6 all squared. So just to show you the fact that keeping consistency, this one is for the blue one and this one is for the green one. Hope that makes sense. Now let's clean it up. So the reason why I kept on saying the fact that do not don't simplify it, right, is that to create your two bracket, you just need this, right? And maybe let's just underline it, right? You just need this alone, just the x alone, and you just need this number alone. Close the bracket all squared. And you also need the same thing here. You just need this y alone and this number alone without the square and close it, right? So what I mean is the following. Let me just go back to black. So this, when you simplify it, the green part is going to be what? It's going to be x minus 6 all squared plus then this is going to be y plus 6. Do you see why I kept even the sign? It's going to be all squared. Then on the other side, right? On the other side, we need to basically simplify this, right? So now let's simplify this. This is basically negative. So this is going to give me what? Negative 54, right? And this is going to be plus 36. Now we can simplify it and plus another 36, right? So now cleaning it up, we know the fact that this is going to be x minus 6 all squared plus y plus 6, right? All squared is basically equals to 18, right? So now we have written this in this form, right? So now taking the center, which is the coordinate q, what we're solving, right? So then q is this, right? So q is what? The x coordinate for it is this one, and we see the fact that it's negative 6, meaning here is going to be positive 6. And the y coordinate here is it's positive 6, meaning outside is going to be negative 6. So it's going to be minus 6. So now we're going to do 4.4. it says determine the equation of AS in the form of y is equals to mx plus c, right? So AX, I'm just going to highlight it. It's going to be this line. Too thick. Okay, cool. Yes, it's going to be this line, right? What do we see the relationship between those two? We see the fact that that line, right, is perpendicular to this line, right? And that is going to be 90 degrees, right? And the reason is radius perpendicular to tangent, right? And the nice thing is that we can find the gradient of this line, right? And since it's perpendicular, we can find the gradient of this, and we have one extra point to find C, right? So we know the fact that OQ, so let me go back to black. So we know the fact that QS is perpendicular to AS, right? And the reason is tangent perpendicular to radius, right? So we know that. So meaning the gradient of QS, right, multiplied by the gradient of what? Gradient of AS is equals to -1, right? So we can find the gradient. So finding the gradient of QS, because we have the complete coordinate. We know the fact that Q is what? Is 6 is to -6, and S is what? Is 3 is to -9, right? So we know that, right? So now we know the fact that the gradient, right, the gradient of QS is basically equals to what? To YQ, right, minus YS, right, divided by what? Divided by XQ minus XS, right? So now let's substitute, right? So when substituting is that YQ is -6, right, minus -9. And that is going to be divided by what? That's going to be divided by 6 minus 3, right? So it's going to be 6 minus 3. So when you punch that into a calculator, you're going to get your gradient as being what? As being equals to +1, right? So you know the fact that it's equals to +1, but you know this relationship. Remember, you know this relationship. So, but you know this relationship, so we can substitute what? We can substitute QS, right? So when we substitute QS, it's going to be 1 multiplied by the gradient of AS is equals to -1. So therefore, the gradient of AS is basically equals to -1. Hope that makes sense, right? So now, with that said, is that I'm going to find C. But I think today I'm going to use this equation, right? To find my equation, it's going to be Y, right, minus Y, then our coordinate, so YS, right, is equals to M, then it's going to be X minus XS, because I'm just using this coordinate. So I'm not going to say Y1, I'm just going to call it YS, because that's what we're using, right? So substituting that is going to be what? It's going to be Y minus -9 is equals to our gradient, which is negative, right? -1 is going to be X, right, minus 3. Then we're going to write this in the form of Y is equals to mx plus c. So meaning making this Y the subject, right? So this is going to be Y, right? So let me just do this. This is going to be the same as Y plus 9 is equals to what? Distribute the negative. So it's going to be negative X, and here's going to be plus 3. So take the 9 to the other side. So Y is going to be equals to negative X plus 3 minus 9, right? So therefore, when you simplify this, it's going to be Y is going to be equals to negative X minus 6. So that's how you would find the equation of the line AS. Hope that makes sense, right? So now it says identify the quadrilateral that is A. So let's just highlight it. So AS, so it's AS, right? ASQR, right? So this. So we see the fact that that is actually a kite, right? And we need to like give reasons why. One is that we see the fact that RQ, and so we see the fact that RQ, right, and QS are both radius and they both equals to each other. And we know the fact that the top part of a kite, they equals to each other. Then remember the fact that AR, right, and also AS are tangent, right? And they meet at the point A. So meaning those two are also equals to each other because of its tangent line meeting at the same point. Hope that makes sense, right? So now we know the fact that this is a kite, right? This is a kite, right? And our reason is that we know the fact that QR is equals to QS, and the reason is radii, right? Then lastly, we know the fact that AR is equals to AS and is tangent at the same point. Tangent, same point. So that is why it's a kite. Hope that makes sense, right? Because this and this are equal and these two are also equal. Hope that makes sense, Anna. So now let's do 4.6. It says determine the scale, right? The scale factor K by which the radius of the circle with center Q, so this circle, right, should be increased so that it touches with the other one. So how much this, right? So touching can be two cases, right? It can touch internally, meaning it grows, that it touch internally like this, right? It can touch, what you call this? It can touch externally, not internally, right? It can touch like this, external, meaning it's outside. It can touch from outside, or it can grow in such a way, the fact that it touch internal, meaning the other circle is inside and it's touching, right? So we have case one, which is external, right? That it grows like this. And we have case two, where it's internal, right? So we're going to look at each, right? I'm going to say case one and case two, and both of them are answers, right? So for case one, touching what? Touching external, right? So case one, or let's just call it touching external, right? So it's going to be touching. So it's going to be touching. So touching externally, right? So what we want to know, let me just show the graph, right? So the graph is going to grow in such a way like this. So the circle is going to grow, make it in red for this one. So it's going to grow. Oh, I don't want it. I want it in red. So the circle is going to grow like this, right? And I'm just going to adjust it like this, right? So to make sure the fact that to test something, two graphs, what you call this, two circles are touching, is that the line between them, so I'm going to make this line, and maybe let's make the line blue, right? The line between the two radius, so the distance between the radius, so the distance between the radius like this, right, needs to be what? If it's touching, so let me just fix this. If it's touching external, right, the distance between the two centers, right, needs to be equals to the distance of the circle, the radius of the circle, and the radius of this circle, right? So what we're looking for, the K factor is this portion, right? So what we're looking for is this. This is the K factor. So let's highlight. This is the K factor that we're looking for. That is K. That we're looking, the K factor, right? So the K factor is basically what is going to be this external, right? The new amount that is added multiplied by the radius of the original, so that we can know how much this circle grew from here to this one. Hope that makes sense, right? So here's the formula, right? So the formula that we're going to use to basically solve for that factor is going to be what? It's going to be PQ, which is the distance between the two centers. So it's going to be PQ, right? Is equals to what? Is equals to the radius of P plus K, which is the factor, multiplied by the radius of Q. We're looking for this Q, right? So that's for when it's external. Hope that makes sense, right? Hope that makes sense. So we're looking for that, right? So now let's put this inside a block so that you know, right? So that's what we're looking for, right? So now let's solve this one, right? We know the fact that PQ, right, is equals to the distance. So it's going to be the square root. So it's going to be the square root, right? So the square root of XP minus XQ, right? All squared. Then it's going to be YP minus YQ all squared, right? Then you're going to put this in the square root. Let's substitute, right? So when we substitute, we're going to have the following. We're going to have that P. So we're going to have that PQ is equals to the square root of what? The square root of X is going to be -3, right? Remember the fact that this is 6 is to -6. So it's going to be -6 all squared plus this is going to be 4 minus -6 all squared, right? Then what we're going to do is that we're going to punch that into the calculator. So we see the fact that PQ is basically equals to the square root of what? Of 181, right? So that we have, then remember the fact that the radius of P, right? We found it. That was one of the first questions that we did. We see the fact that the radius is 5, right? So the radius of P, of center P is 5. Then the radius of Q, right? When we were doing completing the square, we found it as 18, but this is R squared, right? This is R squared, meaning R is basically equals to what? Is equals to the square root of 18. So now we're going to solve for K, right? So substituting, we know the fact that PQ, right, is equals to what? Is equals to RP plus K multiplied by RQ. So we know the fact that this is square root of 181 is equals to what? Is equals to 5 plus K multiplied by the square root of 18, right? So we were trying to make K the subject. So it's going to be square root of what? Of 181 minus 5, right, is equals to what? Is equals to K root 18, right? So that's going to be K root 18. So with K root 18, this is going to be what? This is going to be square root 181 minus 5 divided by root 18. So if it's external, right, then K, therefore, then K, when you punch that into the calculator, is basically equals to 1,99. So this is how much factor it will grow so that it touches external. But I said the fact that that's condition 1. Then now we need to look at condition 2, right? So now condition 2, we said the fact that it's internal, meaning it's outside, meaning the circle grows in such a way, the fact that it covers this one with P like this, right? And how do we do that? That is touching internally, right? So now let's draw that circle. So we see the fact that the circle, and we're going to just make it green, right? The circle is going to go like this. This is touching what? This is touching internal. Do you see the fact that they are touching here? Internal, right? So for this one, it's going to be what? It's basically the distance, right? It's PQ, right? It's equals to QR, the new QR, which it's from here, right? And it's still here, right? Minus the distance here. So it makes sense. So the formula for that to find this case, right, is going to be what? It's going to be basically PQ, right? So it's going to be PQ. So it's going to be PQ. So for touching internally, so let's say touching So this is for touching. Why can't I spell? So this is touching internally, right? Internally, right? So the condition is what? It's PQ, right? Which is the distance between the two. So let me just put the distance, right? Is the distance between the two, right? Between the two centers is equals to the new one. So the distance between the two, then the new one minus this one, right? So the new one, you know the fact that it's in this form, right? This is the new circle, right? The new radius of the circle. So let me just do this. K multiplied by RQ is equals to the radius of the new one, right? So it's going to be basically the radius of the new one for testing this condition minus what? Minus the radius of what? Of P, right? So this is the same as PQ is the same as K multiplied by RQ, right? Minus what? Minus the radius of P. Hope that makes sense. And I'm just going to put this in green so we know the fact that that is the condition for the green one. Hope that makes sense, right? So now using that, we're going to solve what? We're going to solve our K, right? Because our first K, this is for when it's external and this is for internal, right? So this is going to be equals to what? So this is going to be PQ is equals to K multiplied by RQ, right? Minus RP. We already have PQ, so that's going to be square root of 181 is equals to K. We know the fact that this is square root of 18 and this is going to be minus 5. So this is going to be the square root of 181 plus 5 is equals to K square root of 18, right? And therefore this is going to be square root of 181, right, plus 5 divided by what? Divided by square root of 18 is equals to K. So therefore we see that our K is equals to what? Is equals to 4,35. So when it's external, then our K should grow by this vector. If it's internal, it must grow by this vector. So now we're going to do trigonometry, right? So the first question, it says, given that sine B is equals to 12 divided by 13, and they tell us where 10 beta is what? So sine beta, sorry. And they tell us the fact that 10 beta is less than what? Less than 0, meaning our 10 is negative. Less than 0 means negative. Then they say with the aid of a diagram without using a calculator, determine the value of sine 2 beta, right? So we know the fact that we need to draw the Cartesian plane. So let's draw a Cartesian plane. And remember, when drawing with the Cartesian plane, our triangle needs to be in only one, right? So the first one is that this gives us the first information. With this one, we ask ourselves, where is sine positive? Because do you see that this number is positive? We ask ourselves, where is sine positive? We know the fact that this is all. Let me go back. It doesn't want to go back. Okay, cool. So we know the fact that this is all. Students, take coffee, right? So we ask ourselves, where is sine positive? Sine is positive in the first and the second quadrant. But remember the fact that we cannot have it in what? We cannot have our triangles in two quadrants. So this gives us the second condition. The second condition says the fact that our 10 needs to be negative because it's less than 0. Where is 10 negative? So we know the fact that it's negative in the second and in the fourth quadrant, right? So where do we see a tick and a cross? Is the second one. So our triangle is going to be here. So you're going to draw the triangle like this. Very important, our line that is perpendicular goes always to the y-axis, not the, which goes to the x-axis, not the y, not this one, but always this line. So we're going to drop it here, just like this. And this is going to be 90 degrees, right? Then from here, then our angle beta is always going to be the angle that's between here. So always like this. Hope that makes sense, right? So now let's fill this triangle, right? So we know the fact that it's sine, so it's opposite, which is going to be 12 here, over hypotenuse, and hypotenuse is going to be the one that's opposite the square, so it's going to be here. So 12 is going to be here, and hypotenuse is going to be 13, is going to be here. And both this one, the hypotenuse, this one is always going to be positive, but this one depends on where it is. We see the fact that it's in the positive y-axis, so it's going to remain positive. Hope that makes sense. So we sorted with that, right? So now we need to find this, right? So always this one, which since it's parallel to this one, it's going to be representing y, right? Because of it's parallel to the y-axis, right? And this one is always going to be x, right? So this one is going to be always x. The reason why I'm saying that is that to find x, right, because x is going to be here, we're going to use Pythagoras, right? So using that is that it's going to be r squared is equals to x squared plus y squared. Let's substitute. R squared is 13 all squared, right? Then we are looking for x squared, right? So it's going to be equals to x squared. That's what we're looking for. Plus y squared is going to be 12 squared, right? So we know the fact that 13 squared is going to give me 169, and this is going to be x squared, and this is going to be 144, right? Take the 144 to the other side, so it's going to be 169 minus 144 is equals to x squared, right? So when we do this, this is going to give me 25 is equals to x squared. So therefore, square root both sides. So it's going to be what? It's going to be the square root of 25 is equals to the square root of x squared, right? So remember the fact that when we square rooting an even number, this is going to be plus or minus. So this is going to be plus or minus. So this is going to be plus or minus 5. And this is going to be x. So now we need to determine x, whether is it negative or positive. We see the fact that it lies on the negative. So therefore, our x here is going to be the -1. So it's going to be -5. So this is going to be equals to -5. Hope that makes sense. So now our diagram is complete, right? So now we answering the question. It says the fact that we need to look for what? For sine 2 beta. But sine 2 beta is an identity, right? Which says what is going to be equals to 2 sine beta multiplied by cos beta. So we already know that sine, right, is equals to what? Go back. We already know it's equals to 12 divided by 13. So it's going to be 2. Then it's going to be 12 divided by 13, right? Then cos. Cos is equals to what? Is equals to adjacent, which is -5. Divided by hypotenuse. So it's going to be -5 divided by 13. So it's going to be what? It's going to be -5 divided by 13, right? So we're going to multiply the entire numerator. So when you multiply the entire numerator, when you say 2 multiplied by 12 multiplied by -5, you're going to get -120. And when you say 13 multiplied by 13, it's going to give you what? 169. And that's going to be your final answer for this question. So now we're going to do 5.2. It says given that cos theta minus, alpha minus theta is equals to cos theta, cos alpha plus sine theta, so basically cos alpha multiplied by cos theta plus sine alpha multiplied by sine theta, right? So it's this identity, right? Then they say the fact that use the above identity to reduce it to being sine. Do you see the fact that here is when it's cos, they want us to do basically prove the fact that using this one, it can be this one, right? So to do that, the most important thing that you need to remember is cofunction, right? Cofunction. So we know the following about cofunction. We know the fact that I can change, if let's say I have sine, right? If I have sine theta, right? Then I can rewrite sine theta, or maybe let's just make it in x because we have theta here. If we have sine x, right? I can write sine x as being what? As being cos 90 minus x. This is exactly like this. Same thing, right? And vice versa, right? Meaning if I have cos, so if I have cos x, I can basically write it in cofunction. I can write it as sine 90 minus x. So this can be written as this. So knowing that, what we need to do is that we need to reduce, basically use this identity, right? So we need to use this identity to prove this. Basically, that's what we want, is that we need to use this identity, very important, to prove this. So to do that is that I need to change this so that I can be able to apply this identity, right? So using what I just told you is that we know the fact that we're going to have sine alpha minus theta, right? And remember the fact that the alpha minus theta is the same as x, right? So I can rewrite this as cos. So this is the same as cos, and this is going to be 90. Instead of x, we're going to have minus what? Alpha minus theta. Hope that makes sense, right? So that's what we have, right? So our next goal is to basically group this and this together and also have a minus in between. So what we're going to do, the first step is that we're going to distribute the negative. So you're going to say cos, right? Then when we say cos, it's going to be 90 minus alpha plus theta. Then our goal is to group this two, right? So I'm going to put that one inside a bracket. So it's going to be equals to what? It's going to be cos, and this is going to be 90. So let me just put it in the square bracket. Right, so it's going to be 90 minus alpha inside a bracket. Then we're going to have what? Plus theta, right? But we do not want plus theta. Square bracket is not curve. Square bracket, right? But we want the angle this in between these two, because I'm just taking them as a whole thing. This is like a whole angle. So this is like a whole angle. So this in our identity, right? This yellow part represents this, right? When we basically applying the identity, and the red part will represent this alpha, right? Because of I need to be able to apply this. So that's why I'm highlighting so that you can see. We see that the problem between the yellow and the red, right? What do we have here in our identity that we need to apply is that we have a negative and here we have a positive. But we know something. We know the fact that we can change a negative multiplied by another negative gives you a positive. So we can rewrite this as being cos square bracket is going to be 90 minus alpha minus open bracket minus theta, right? Square bracket. We know the fact that when we multiply this two, we go back to here. And again, this represents what? This will represent the red part, right? Which is now this one. And this one is going to be the yellow part, right? So now we have that. So now we can apply the identity, right? So this is basically equals to identity. So we know the fact that this is going to be yellow, right, in terms of applying the identity, and this is going to be the red part. So let's do that, right? So applying the identity is going to be what? This is basically equals to cos, then the yellow of our yellow is 90 minus alpha, right, multiplied by cos, and our red is negative theta, right? Then it's going to be plus, right? It's going to be sine of our yellow is going to be 90 minus alpha, then multiplied by sine negative theta, right? So now we can clean this up. So when we clean this up, we know the fact that this is a cofunction, right? Since it's a cofunction, we know the fact that cos theta, remember when I gave you this, when I gave you the two cofunction, we know the fact that cos 90 minus theta is going to give you sine. So this is the same as having sine alpha. Then a negative angle, when you say cos of a negative angle, is always going to be positive. So this is going to be multiplied by cos theta. Then this is going to be plus, right? So this is going to be what? This is going to be cos alpha. Remember from here. So this one becomes this one, right? Then lastly, this one, a negative, right? A negative of a sine. If we have sine inside the negative, it's going to be negative. So it's going to be negative sine alpha. Let's just put this as being note. We know the fact that cos of a negative angle is equals to cos positive. And we know the fact that sine of a negative angle is going to be negative sine x. And lastly, tan of a negative angle is also negative. So only cos is going to be what? It's going to be positive. Let's put this in the square bracket. That's something that you guys need to remember, right? So now let's clean this up, right? We know the fact that the first part is going to be sine alpha multiplied by cos alpha, but taking the negative in front, so this is the same as minus, because a positive and a negative becomes a negative. So this is going to be cos alpha, then this is going to be sine alpha. Now doing 5.2.2, it says hence otherwise, right, evaluate this. So the hence part, right, so our hence part is using the previous question. So what did we prove in the previous question? That this identity. So we were proving this identity, right? So that's our hence. So our hence is that identity. So meaning it's going to be what? Our identity is sine, and that is alpha minus theta is equals to what? Is equals to sine. So it's going to be sine alpha, right? Multiplied by cos theta minus what? Minus cos alpha multiplied by sine theta. So this is our hence, right? So looking at our hence and looking what we have, right? So what are we given? We given, so let me just put this inside a block, right? So what are we given? We given the fact that we have sine 76, right? Multiplied by sine 44. Then minus sine 14, then sine 46, right? So I'm gonna color coordinate it like the way we did there, right? So meaning in our case is that alpha, right? Alpha needs to be the 7, this gonna be, so alpha is gonna be the ones that I highlight. So that's our alpha, right? So meaning this two needs to be the same, then, or the whole thing, yes. So alpha is going to be the ones that we highlighted. Then our theta is going to be the one that we highlighted too, right? So that's going to be the ones that we highlighted. And we're just going to compare. So we see the fact that that's what we have. What do we see, right? We see the fact that, and I'm going to put ticks on the ones that we're keeping, right? We see the fact that here we have what? We have sine, right? 76. Then, in our case, we have sine 44, but here it needs to be cos. So this one we're keeping. Go back. So we're keeping this one, right? But we need to change this one, the one that I didn't put a tick on it. Then we see the fact that it says the fact that is what? It's cos, right? So this one is, it's cos, right? And this one is sine. So we're keeping this one. Go back. So we see the fact that there's two are both sine, so we're keeping that too. Hope that makes sense, right? So meaning what we're looking for from what we're keeping, we're looking for 76 and 44, right? Being our alpha and our theta. Hope that makes sense, right? So to change this one, we're going to use cofunction, right? So to change this one and this one, we're going to use cofunction. So we know the fact that on the side, we know the fact that sine, right, 44 is basically equals to what? Sine 44 is basically equals to cos 90 minus what? Minus 46, right? So which is going to match up exactly with this one. Because when you say 90 minus 46 is going to give you 44. Hope that makes sense, right? Then we also see the fact that sine 14, so sine 14 it's basically equals to cos 90 minus 76, right? Because if you say 90 minus 76, you're going to get 14, which matches up with this one, right? So we know that, right? So now using reduction, right, this is the same as what? This is the same as having cos 46, and here's the same as having cos 76. So now let's substitute. So when we substitute, let me just put this here, right? So when we substitute, we know the fact that we're going to have sine 76, we're keeping that, but we're going to change sine 44. So that is going to be cos 46, right? Then we're going to change what? Sine 14, which is going to be minus what? Cos 76. That's going to be multiplied by sine 46, because we're keeping that one. And that is basically equals to this identity, right? Which is going to be sine. And remember the fact that alpha is 76, so it's going to be 76, because that's the red one from highlighting. Do you see? Then 44 is going to be what? It's going to be our theta. So it's going to be minus 44. We find that that is going to be equals to sine 30 degrees, right? So now you can use a calculator. They're not going to know. So when you punch this into the calculator, you know the fact that this is going to give you a half. So that is how you would solve this question, Anna. So now we're going to do 5.3. It says, given that f of x is equals to sine x, then they say that show that this, right, can be written in terms of this. So what we're going to do is that we're going to basically substitute f of x here. Then we're going to first find f of x plus h, then clean this up so that it can look like this. So let's do that, right? So we see the fact that we need to show that this can be equals to this, right? So we have f of x. So we see the fact that we have f of x as being equals to what? To sine x, right? Then we have f of x plus h. I'm gonna do it outside first so that I don't make any mistakes, right? So now wherever I see wherever I see x, right, I'm going to substitute by this. So we see the fact that that is the same as sine x plus h. And we see the fact that this is an identity from our previous question. Do you see this hence this identity, right? So using the identity, I'm just going to write it down here. So we know that the identity says what? It's going to be sine. It's going to be what? Let me say a plus b, right, is equals to sine a multiplied by cos b, right, plus then it's going to be what? It's going to be cos a multiplied by sine b. Let me just double check the fact that is it the right one. Okay, yes, so that is the right one, right? And I'm going to put it inside the square. So I'm going to apply that identity right here. So we know the fact that that's basically going to be equals to what? So f of x plus h, applying the identity, is the same as having what? It's the same as having sine x, right, multiplied by cos h plus cos x multiplied by sine h, right? So we have that. Then after having that is that we're going to basically clean up the numerator. So we know the fact that that is f of x plus h minus f of x is equals to, we know the fact that this is going to be sine x multiplied by cos h plus what? Plus cos x multiplied by sine h minus f of x, and f of x is just sine x. So it's going to be sine x, right? So we have that. Then I'm going to substitute it back here. Remember the fact that we're looking for what? For when f of x plus h, right, is equals to what? Is minus, what you call f of x plus h minus f of x, right, is divided by h. So now let's substitute our numerator, which is this one, right? So it's going to be what? It's going to be sine x minus cos h plus what? Plus cos x multiplied by sine h, right, minus sine x. And this whole thing is divided by what? Is divided by h, right? So now what I'm going to do is that I'm going to pull up what they want us to prove, right? Remember the fact that they want us to prove this. This is what they want us to prove, right? So I'm going to pull it up and put it here. So when I'm pulling it out, I'm just going to do this. I'm just going to write it. Let me just unzoom it here. because I just want it here. So we know the fact that what we want is this one, because I just want to see what we're looking for, right? Sine h, sine x, then it's going to be cos h minus 1 divided by h, right? And this is going to be plus cos, then this is going to be cos x, then it's going to be sine h divided by h. So that is the goal, right? This is our goal, right? Let me just do this, put inside the block. So knowing what we need to achieve is that I see the fact that sine x is like a common factor, so I'm going to group them, right? Do you see the fact that if I group this and this as being together, is that I can take out the sine x as a common factor? So I'm going to put it here so that I can group it, right? Then I'm going to have this, right? So let's do that. So we know the fact that this is the same as sine x multiplied by cos h, right? Minus sine x, then this is going to be plus cos x multiplied by sine h, right? And this whole thing is divided by what? Is divided by h. I see the fact that I can group this two together and this two, right? Then now we have what? We can take out sine x, so we have sine x, and we're going to left with cos h minus 1, right? And this whole thing, oh sorry, plus this is going to be cos x. Then I'm just going to put sine sine h inside a bracket, right? So it's going to be sine h inside a bracket. And do you see the fact that we're becoming closer to the numerator here? This, do you see this is becoming close? Do you see that? And this whole thing is going to be divided by h, right? But we see the fact that we can distribute the h throughout, right? So if I say sine, this is sine x, ooh, yes, sine x, yeah. If I say sine x, right, then it's going to be cos h minus 1, right? This whole thing divided by what? Divided by h, right? And this is going to be plus what? Plus cos, I'm distributing the h. So cos x, then this is going to be sine h. It's also divided by what? Divided by h. So what happened is that here, what they did is that they just distributed the h only to the ones that are in the bracket, and that's what we're going to do. And we're going to get exactly, because we could do that, right? Because it's multiplication. So just distributing the h there, so meaning it's going to be sine x, sorry, and it's going to be cos h minus 1, and this whole thing, so basically, yes, this whole thing is going to be cos h minus 1 divided by h, right? Because we can do that. Then this is going to be plus cos x, and this is going to be sine h divided by h. And this is exactly what they want us to prove. And we're done proving the fact that we can rewrite that as being equals to this. So this question uses reduction, so we're going to use this. So it says simplify the following to a single trig ratio without a use of a calculator. So what I'm going to do is that I'm going to do the numerator and the denominator, taking individuals, right, and sorting them out separately, then putting them back, right? So that's what we're going to do. So we see the fact that the first one is what? Is 180, right? 180 minus x. Then we're going to go back to the diagram. Let me just erase this, right? So we were looking for 180 minus x. So theta here would represent x, right? So 180 minus x. So let's go back. 180 minus x, 180 minus x. So it's this one. So we know the fact that our 10 becomes negative theta. So meaning here, it's going to be equals to what? It's going to be equals to negative 10x. Hope that makes sense, right? So that's what we're going to have, right? Then the other one is cos. So it's cos 180. So it's cos 180 minus x. So go here. We're looking for cos. 180 is going to be negative also. So this is going to be what? This is going to be equals to negative cos x, right? Then we're going to deal with cos 240, right? So cos 240, you can write 240 as being what? And saying cos, right? So if you say cos, right, if you say cos, then you say 180 minus what? 180 plus 60. So what I did is that I reduced this, right, into being one of the, like, from the reduction. Hope that makes sense, right? So I tested it out and I see the fact that since they said without a use of a calculator, meaning when I reduce this, I need to get like a spatial angle. And I know the fact that 30, like what you call the 0, 30, 45, and 60, 180, and 360 are spatial angles, right? So I see the fact that if you punch in 180 plus 60, you're going to get 240. So that's what I reduced it to. So I know the fact that I can reduce this one now, right? Because I'm looking for cos plus. So if I go here and I'm looking for cos plus, what you call this 180 plus. So 180 plus cos is going to be this one. So it's going to be negative theta cos. So this is going to be what? This is basically going to be equals to negative cos 60. But 60 is an identity. So this is the same as what? Minus 1.5. Hope that makes sense, right? So we have what? We have this sorted out, we have this sorted out, we have this. Now let's clean up this one, right? So cleaning up that one, we see the fact that we have what? We have 10 squared y minus 1 divided by cos squared y. So we need to clean this up, right? So we know the following, right? We know the fact that this can be written as an identity, right? So we know the fact that this is the same as 10 squared y, not 10. This being an identity. So the identity, I'm just going to write it here. So the identity that we're going to apply is sine squared y divided by cos squared y. So let's apply the identity. Let me put this inside a block. So we're going to apply that identity. So applying that identity, we know the fact that we're going to have what? We're going to have sine squared y divided by what? By cos squared y minus 1 divided by cos squared y. So I'm just going to move this here, right? So now applying that identity, we know the following. We know the fact that our denominator is the same, so making the same LCD. So this is the same as sine squared y, right? Minus 1, and this whole thing, right, is going to be divided by cos squared y. But applying another identity, right, and I'm just going to write the identity here, is that we know the fact that if I apply this identity, we know the fact that we have identity which is sine squared y plus, and I'm just going to make it in terms of y, right, cos squared y is equals to 1, right? But making making cos squared y the subject, this is the same as having cos squared y is equals to 1 minus sine squared y. So now using this identity, we see the fact that here the only difference between those two is that the signs are different. Here our sign is positive and here is negative, and our one is positive and here is negative. So let's swap them first, right? Write it in the correct order. So this is going to be the same as negative 1, right, plus sine squared y, and that is going to be divided by what? That is going to be divided by cos squared y, right? But we can pull out the negative so that we have them in the right form, right? So this is the same as what? Having minus. So whatever that was negative becomes positive, and whatever that was positive becomes negative. So this is going to be 1 minus sine squared y, and this thing is divided by what? Is divided by cos squared y. So substituting, so we know the factor is going to be minus cos squared y divided by what? Divided by cos squared y, which is the same as it's equals to negative 1, right? So now we can go back and substitute here, right? So we know the fact that our original equation, we have what? We have 10, 180 minus x. multiplied by what? By cos 180 minus x, and this whole thing is divided by what? Is divided by cos 240, right? Multiplied by that whole thing, which is cos squared y, right? Minus 1 divided by cos squared y, right? So now let's substitute. We know the fact that this one became negative 10x, so it's going to be negative 10x. And this one became negative cos x, so minus cos x. And this whole thing is divided by, this one became a negative a half, so it's going to be minus a half. So it's going to be minus a half. And this whole thing, right, became negative 1. This whole thing became negative 1. So it's going to be minus 1. So let's clean it up a little bit further. We know the fact that we're going to have a negative and a negative becomes positive. So it's going to be 10x multiplied by cos x. And this whole thing, a negative and a negative is going to give you what? A positive. So it's going to be minus. It's going to be minus a half. So it's going to be minus. It's going to be positive a half. So it's going to be positive a half. Sorry. It's going to be positive a half. Right? So now I'm going to just flip the negative to the other side. So rewriting it like this, which is going to be 10x multiplied by cos x is the same as divided by a half. Right? So this is the same as what? This is the same as 10x multiplied by cos x multiplied by, then swap them, meaning it's going to be 2 divided by 1, which is going to be the same as 2. So now we know the fact that this is basically what? This is the same as 210x multiplied by cos x. But remember, we need it in a single trig ratio. So I know the fact that 10x is an identity. So I know the fact that 10x is going to be the same as sine x divided by cos x, right? And this is multiplied by cos x. Since everything is multiplying, meaning this and this are going to cancel out. So you're basically going to be left with what? You're going to be left with 2 sine x. And let me just write the identity here, that cos x is basically equals to sine x divided by cos x, and put inside a block. So now what we're going to do is 6.2, right? With 6.2, we need to prove that these two are equals to each other. So we need to take one of the sides and reduce it so that it can match up with the other side. So the one that I see I can basically reduce is the left hand side. So I'm going to name it so that I know this is the left hand side and this is the right hand side. As I said, the goal is to check whether both sides are equal. So we're basically checking whether the left hand side is equals to the right hand side. So taking the left hand side, which is going to be equals to sine 3x, right? And this is divided by what? Is divided by sine x multiplied by cos x, right? So we see the fact that in the numerator we can't do much, but I can do something with the denominator, with what you call this, with the numerator. With the denominator I can't do much, right? Is that I can write this as being what? As being 2x plus x, right? Where this 2x is going to be another identity, and this 2x plus x is going to be an identity on its own. Hope that makes sense, right? So I know the fact that I can write this as being what? The numerator as being sine, right? Sine 2x plus x. And this whole thing is going to be divided by what? It's going to be divided by sine x multiplied by cos x, right? So now I'm going to apply the identity, and I'm just going to go up because we already have that identity. Let's go up. Yes, I'm going to apply this identity. Duplicate, cut. So applying this identity, right, I'm just going to put it here on the side, right, is that I'm going to have what? So let me just move it a little bit further so I can have space, right? So applying this identity, the numerator now is going to be what? It's going to be sine 2x, right, multiplied by what? By cos x, right? and this is going to be plus cos 2x, right? And this is going to be multiplied by sine x, and this whole thing is going to be divided by what? Divided by sine x multiplied by cos x. Hope that makes sense, right? So now we know the fact that this is equals to what? Is equals to an identity, and I'm going to write the identity, right? So we see the fact that sine 2x is equals to this, but cos 2x has 3 options. So you need to be able to pick which one is the best option, right? So now let's deal with this one because of it has only one option, and we're going to come back to this one, right? So we know the fact that this is going to be basically equals to sine, sorry, not sine. It's going to be 2x. So it's going to be 2 sine x multiplied by cos x, and multiply again by cos x, right, because of this cos x, and this is going to be plus cos 2x multiplied by sine x, and this whole thing is going to be divided by what? This whole thing is going to be divided by sine x multiplied by cos x. So now we're going to go back and check what we need, right? We're going to look at what we have and basically what we need, right? So let's clean this up further before even applying this one. You'll see where we're going with this, right? So let's do that. So it's going to be what? It's going to be 2 sine x, and the cos is going to be multiplied by cos squared x, and this is going to be plus what? Cos 2x multiplied by sine x, and this whole thing is going to be divided by what? By sine x, and then cos x. Then now, going back, we see something, right? Is that we're looking for it to match up with this, right? So we see the following. We see the fact that we have cos in the denominator and we have cos here, meaning we need to get rid of the sign. The sign needs to be we need to get rid of it, right? So first that sign needs to be get rid of. Then in the numerator, we need just cos. So there isn't any sign. And we see something, right? If we look at this, even before applying again, I'm not going to apply it because I need the best situation for it, right? Is that when I apply, is that I need the following. Is that, do you see the fact that here we have sine and sine, right? So let me take out sine as a common factor. Right? So let me take out sine as a common factor. So we're going to have this. So it's going to be 2. No, not 2. Take out sine as a common factor. So it's going to be sine x, open bracket, you have 2 cos squared x, right? Plus cos 2x, right? See? We took out sine as a common factor. So here we left with this, and here we just left with this, right? And this whole thing is going to be sine x multiplied by cos x. And you see the fact that we're coming closer to what we want, because we see that this and this are going to cancel out. So we see this 2 are going to cancel out. So we left with 2 cos squared x plus cos 2x. And that is divided by what? That is divided by cos x. Right? So do you see the fact that now my denominator matches up with this, right? And now we have this, and everything is in terms of cos. But now we need to apply the identity here. So looking at our 3 options, is that we can apply the first one because of it as sine. We do not want sine from what we want to achieve, right? And also we cannot apply this one because it has sine, but the only one that we can apply is this one. So let's apply that one, right? So now applying that one, we're going to have what? It's going to be 2 cos x, then, right, it's going to be what? It's going to be plus, then it's going to be 2 cos squared x, then it's going to be minus 1. So it's going to be minus 1, right? And this is going to be divided by what? Divided by cos x is equals to, then it's going to be 4 cos squared x, and it's going to be minus 1. And that is going to be divided by cos x. And that is exactly what we want. which is equals to the right hand side. Do you see why I waited to apply this? Sorry. Do you see why I waited to apply this? Because of I need to check from my situation which one is the best scenario, right? So you do not rush by adding, because you could just expand it and have unnecessary working out. Hope that makes sense, Anna? So now we're going to do 6.3. It says determine the general solution of cos x plus 1 is equals to sine x. So let's write it. So it's going to be cos x. Okay, cool. Let me zoom it in. So we have cos x plus 1 is equals to sine x, right? So here, even if we take this one to the other side, it's not going to change anything. So our goal is to change one of them into being what? Into being a sine or cos, right? So the easiest way to do that is that we're going to square both sides, right? If we both square both sides, is that this is going to be squared and we're going to use an identity. And the identity that we're going to use, remember the fact that we have sine x, right, plus cos x. What you call the sine squared x plus cos squared x is equals to 1, right? So if I'm looking for just sine, it's the same as what? Making it the subject here, which is going to be sine squared x is equals to 1 minus cos squared x, meaning now everything is going to be in terms of cos, so it's going to be easy to work with that. So the first thing that we're going to do is like to basically square both sides. So let's square both sides. So now let's expand the other side. So when you expand this side, you're going to have what? You're going to have cos squared x, right? Plus 2 cos x. Then it's going to be plus 1 is equals to sine squared x. And remember the fact that we're going to replace the sine squared x by this. So let's replace it. So here you're going to have cos squared x plus 2 cos x plus 1 is equals to what? Is equals to 1 minus cos squared x. Let me just put this inside a box. Yes. Right? So now everything is in terms of cos, which is perfect. So I'm going to send everything to one side so I can factorize it, right? So we see the fact that we have cos squared x, right? And this is going to be cos squared x, then it's going to be plus 2 cos x, then it's going to be plus 1. This is going to be minus 1, right? And it's going to be plus cos squared x is equals to 0. So like terms. We see the fact that this and this are a like term. Then also this 2 are like terms, right? So we're going to have those 2 in red is going to give me 2 cos squared x. Then it's going to be plus 2 cos x. Then the yellow ones, since the other one is positive and the other one is negative, it's going to be 0. So this is going to be equals to 0. So they're going to cancel out. So we see that 2 cos x is a common factor. So we're going to take that out as a common factor. So you're going to have 2 cos x. Here you're going to be left with just cos x, and the other one you're just going to be plus 1 is equals to 0, right? So equate both by 0. So it's going to be 2 cos x is equals to 0, or it's going to be cos x plus 1 is equals to what? Is equals to 0. So here is the same as having cos x is equals to 0, because 0 divided by 2 is going to be 0, and the side is going to be the same as cos x is equals to -1. So now we're going to find basically the general solution of this and this. So we're going to start with the cos x is equals to 0. So 4, let me just say 4 cos x is equals to 0. We need to find the reference angle. So the reference angle is equals to what? Is equals to our cos. So it's going to be a cos of this number, right? So in our case, it's 0. And we're going to find the fact that that is 90. So since 0 can be plus or minus, it's just going to be 90, right? And you're just going to be, the answer for this one is going to be just x is equals to the reference angle, which is going to be 90 plus, then it's going to be 360 multiplied by k, right? Hope that makes sense. because since we're not going to have it as being plus or minus, so, and we know the fact that k is an element of real numbers, I'll just write it at the end. So now that's that. Now moving to this one, right? Let me just do it here. For cos, right? Cos x is equals to -1, right? So we need to find the reference angle. So the reference angle is going to be equals to a cos, right, of 1. Not the negative. We never use the negative, just the positive, right? So it's going to be that. So we know the fact that this is going to give me what? It's going to give me 0, right? So our reference angle here is 0. So now using the Cartesian plane, right, you're going to see where we use the negative. So let me just put it here. So let me just delete this. Yes. So our negative tells us where our solution is going to lie. They tell us the fact that cos is negative. So it's cos negative. It's negative here and here, right? So we see the fact that here it's going to be what? It's going to be 180 minus the reference angle, right? And here it's going to be 180 plus the reference angle. So now we're going to do question 7, right? So with question 7, it says in the diagram below, the graph f of x is equals to -2x, right? And it's drawn below, so that's what we have. And they tell us the fact that it's within this interval. So we know the fact that we're dealing with cos, right? So they tell us the fact that what is the period? So since we're dealing with cos, is that we're going to use this formula, right? Is that the period is equals to what? Is equals to 360 divided by b. And b, this is absolute, meaning any number that's inside here becomes positive, right? So where do we see the fact that this b lies? Here, the b is here. Do you see? B is in front of x, so this 2. So now finding the period for this question is going to be what? It's going to be period, right? Is equals to 360 divided by the absolute of b. We see that b in our question, right, is this one. So it's this 2, so it's going to be equals to 2. So substituting is the same as 360 divided by the absolute of 2, which is the same as 360 divided by 2, which is going to give me 180. So now we're going to do 7.2. It says find the range, and this is the formula on how to find the range if you're dealing with cos and sine, right? So we see the fact that from our formula we need a and we need q, right? A is the coefficient of the trig ratio and q is the number that's outside. So let's go up. We see the fact that our our a is this -1, right? And our q is 0 because there isn't any number. So now we see the fact that we need a. So we see that a is equals to what? Is equals to -1. And we see that q is equals to 0. So now finding the range, we're going to substitute. It's going to be y is an element between what? Negative, the absolute of -1. Right? So absolute of -1 plus 0, right? And this is going to be the absolute of -1 plus 0, right? So now let's clean it up. Y is an element, then this is 1. Absolute of a negative number is still negative, so this is the same as negative. So this is the same as -1 plus 0. Right? Then absolute of a number, of a negative number, is positive because that's what absolute does. It makes anything, whether it's positive or negative, still positive, right? And this is going to be plus 0. So therefore, y is an element of -1 till +1. So what we're going to do is that we're going to sketch the graph using your calculator. So you're going to go to mode, then you're going to go to, with mine is option 7, but you're going to go to table. So you're going to click 7. Then the function is 10, right? Then it's going to be x. So with x, you're going to say alpha. Then you're going to say x minus 45, right? Then you're going to close the bracket. Then you're going to say equals to. We do not have g of x, so we're just going to say equals to. Then we're going to start at, they said the fact that it's between -180 till +180. So we're going to start at -180, right? Then you're going to say equals to. It ends at +180. Right? Then steps of 45. Always make it steps of 45. With 10, always make it steps of 45. Hope that makes sense. Then you're going to say equals to. Then I'm just going to have this on the page. Like I'm just going to draw this entire thing. Do you see the fact that this table inside? Then we're going to sketch using that. So now let's sketch the graph. But before even sketching the graph, I'm just going to emphasize the point, the asymptotes, right? So the asymptote is going to be here. So we know the fact that at negative 45 and positive 135, that's going to be where our asymptotes are going to be, right? So let's put them first. So I'm going to just put dotted lines there. So let me just change this into dotted lines. So we know the fact that at negative 45, it's just going to be this line. I'm going to make it in red. So this one, that's our asymptote. Go back, sorry. Yes, so it's going to be this line here. That's going to be our asymptote. And another one is going to be this one, positive 133, right? So we have that. Then the next one is our x-intercept, right? Our x-intercept is wherever where we see 0, right? So do you see the fact that where I see 0, that's going to be our x-intercept, right? So that's going to be there. So I'm going to put like at negative 35, I'm going to put like just a dot there to indicate the fact that this is going to be where the graph cuts. Then also where, so it's going to be also at 45. So that's what we're going to have, right? And then I don't know why did I make that negative. Then we know the fact that we have the y-intercept. That's when x is equals to 0. So that's going to be here, right? You see this one. Then that's going to be where, so it's going to be cutting the x-axis where here at negative 1. So negative 1, it's here. So the graph needs to cut through that point. Hope that makes sense, right? So we have that. So now to have the shape in completion, right, is that we're going to be looking at when it's negative 1 and when it's positive 1, right? Because that's where the graph like basically curves up, right? Hope that makes sense. So we see the fact that we have our 1 and negative 1 way. So I'm just going to change the highlighter here, here, and here, and here, and here, right? So I'm just going to make it a different color. Maybe let's make them orange, right? So we see the fact that at negative 180, so negative 180 and then negative 1. So here, this is where the graph curves, right? So that's where it curves. Then we see the fact that at 90 and 1, so this is going to be here, right? We see the fact that we have at 0 and negative 1, so it's going to be 0 at negative 1, which makes sense because it's cutting the x-axis, so it's going to be here. Makes sense, right? Then we see the fact that we have at 45 and we have at 90 and positive 1, so it's going to be here, right? And lastly, we're going to have 180 and negative 1, so it's going to be here. So now drawing the graph, it's going to be like this. So you're going to connect this two going down like that, right? Then connect this two, then like this, right? Because we know the fact that it shouldn't touch the asymptote. Then have this, right? So this one, let me just put it like this, yeah, right? So you're gonna have that, right? And this also continues because, okay, cool, we'll just add the arrows after. So we know the fact that it goes there, then there nothing happens, right? So also here we know the fact that it's gonna cut through, so it's gonna be like this. Do you see? Then it's gonna go up like this. You see? Then that's that. Then lastly, here is that, do you see the fact that there's nothing? So it's going to be just like this. So now we're going to do 7.4. It says for which values of x is f of x less than or equals to g of x for which the interval is between this. So taking this graph, so I'm just going to copy and paste it, right? So I'm going to just take it because we're going to use it to basically answer our question. So cut it and we're going to put it here, right? Then I'm going to explain what they want. So what does it mean when they're looking for what? For f of x is less than or equals to g of x. So we're looking for when this one, the one that's eating the inequality, is at top and we're looking for this one, where the one that's not eating the inequality is at the bottom, right? So we know the fact that this one is red, right? We know the fact that this one is the red graph, right? So go back. We know the fact that this one is the red graph, and we know the fact that f of x is the black one, right? So we're looking for when the red graph is at top and the red graph is at the bottom, right? Then they tell us the fact that which value. So values of x. What are values of x, right? Values of x is the following. Since we're looking for this type of conditioning, we're looking for the intersection. So we're looking for the intersection, right? We're looking for the intersection of f of x, right, and g of x. So we're looking for the intersection. So that's why we're going to divide our graph. But since we're dealing with g of x is what is a tangent, we're also looking for an asymptote. So asymptotes. So that's what we're looking for, right? So we know the fact that they gave us a restriction. They said the fact that it's between these two, right? Our answer needs to be between negative 180 or negative 180 and 0. So first is that we're going to basically cut off the boundaries, right? I'm going to just emphasize them with this. This is where our solution is to lie, between this black part. So we see the fact that another intersection is also here, right? So it's 1, 2, 3 intersection, and also it's going to be the asymptote. I think the asymptote kind of went out. This was the asymptote, so this is going to be the asymptote. So you're going to just draw lines through the asymptote and the intersection. So let's just do that, right? So we're going to draw lines on that. So this one is going to be also a draw line, right? So it's going to be the first portion here. This is going to be the second portion. This is the third portion, and this is the fourth portion, right? Then within each portion, you're going to ask yourself, is our g of x at top and our f of x at the bottom? Meaning we're looking for when the red graph is at the top and the black one is at the bottom. So we're going to start with the first portion, which is this one, right? From negative 180 till negative 130. We see, yes, the red one is at top, right? Then the black one is at bottom. So this is part of my solution, right? Then we're going to move to the second portion, which is this one, right? And we see the fact that from negative 130 till 90, the black one is at top and the black one and the red one is at the bottom. So this is not part of my solution, right? Then we're going to move to what? We're going to move to the third one, right? Remember the fact that we're looking for what? When red is at top and black is at the bottom. We see the fact that, yes, do you see the fact that the red one is at top and the black one is at the bottom? So this is part of our solution. Then lastly, we're going to look at the fourth part, right? We see the fact that red is at the bottom and black is at top. So this is not part of our solution. So our solution, right, is going to be what? Our solution here is going to be this portion. Maybe let me just put it in green. So this is going to be our solution. This portion here and this portion. So let's write it. It's going to be what? It's going to be x, black. So it's going to be x is an element, right? So let's go back. Do you see the fact that they said less than and equals to? So it's going to be square bracket. So here it's going to be a square bracket, right? And also here is going to be square bracket, but here is going to be curve, because remember the fact that this one is an asymptote. So this one can't be a square bracket. So it's going to be what? It's going to be square negative 180 till negative 135 degrees, or it's going to be square bracket. It's going to be negative 90, right, till negative 45, but not square bracket, curve bracket. So now we're going to do 7.5. It says find the maximum value of h of x is equals to this, where x is an element of real numbers. If you have watched my MBT, master series, right, is that this is actually, I covered more questions that are related to that. And the question that we like that is similar to that is this one, right? Is similar to this. So to get more practice on this type of questions, please go do the master maths. I'll just put this as like the questions that you need to just go check so that you familiarize yourself with this type of question. Hope that makes sense. It's going to make sense when you watch the whole thing on how it works, right? Just wanted to say the fact that I've actually dealt with intensive, right, questions that are dealing with this. Hope that makes sense, Anna. So as I said, the fact that we're going to use the notes from the MPT, right, to basically do this question. As I said, the fact that there's more questions, I would actually suggest for you to go and watch that section so that you can understand the different type of questions that they can ask, right? So the first thing that you need to do is to analyze the base, right? So the base in our case is 4. We see the fact that in this case, right, our base is what is positive, right? So let me just do this. So let me just delete this so that we can edit this, right? So our base is 4, right? So our base is 4. And since it's 4, that means the fact that it's going to be increasing, right? So it's increasing. So our base is going to be increasing. 2 and 4, they both mean the same thing. It means the fact that it's increasing, right? So we see the fact that in our case, our base is 4, right? That means it's increasing. So our graph is going to look like this. It really matters when it's increasing and when it's decreasing, because if we're going to be looking at, if we're looking for a maximum value and if we're looking for a minimum value. In our case, they said the maximum value. So I'm just going to look at the maximum part of it, right? But there's notes if you had to look at the minimum value. So with the maximum value, they say, since we know that the function is increasing, see, we going back to this, right? That means that we need to take the largest value in the interval because we want the maximum, right? So obviously, if it's decreasing, the condition is going to be a little bit different. Hope that makes sense. So now, how do we find the interval? The interval, normally in certain questions, they will tell you the interval, but if it's you dealing with trig, right, is that they don't tell you the interval. You kind of need to solve for the interval. So since we're dealing with trig, is that the interval is basically the range. And let me just add, because we're dealing with trig, right? We dealing with, so we're dealing with trig. So that's the reason why, right? And you'll see why, right? So with that said, let me just apply everything that we have. So let me just put this in a block, go back to the block. Let's see, yes. Okay, so now we know the fact that we need the interval. The reason why we need the interval first is that from the interval, we can pick the largest number, right? So we see the fact that our question is h of x, right? So h of x is equals to what? Is equals to 4. Then the power is what? Is 2 sine. So it's 2 sine squared minus what? Minus 1. 2 sine x minus 1. Very important. It's trig. And we're looking for the interval. And let me just add there. And the range that we're looking for, the range is of the exponent. So we only care about the exponent, right? So now let's sort out this exponent. So what you call this? Simplifying the exponent. So we simplify the exponent, right? So we know the fact that we have 2 sine squared x, right, minus 1, right? So we see the fact that we have that. So now with having that is that we know the fact that that can be written as a trig function, right? And the trig function, the one that we're going to use is going to be this identity. So let's go back, right? So we're going to go back. You'll see the fact that which identity we're going to basically apply. So we're not going to apply this one. We're not going to apply this one. We're actually going to apply the ones from here. So let me just duplicate it and cut it. And we're going to go down. And you're going to see something. So applying this identity, we know the following. We see the following, right? We see the fact that, you see the fact that this and this looks a little bit similar. The difference is the sign, how it's arranged, right? So let's rearrange it, right? So when we rearrange it, it's the same as having what? It's the same as having -1. So this is the same as having -1 plus 2 sine squared x, right? So we want this one to be negative, and we want this one to be positive. So we're going to pull out the negative. So this is going to be negative, then this is going to be positive, and this is going to be negative. This is going to be sine squared x. Then we see the fact that that is basically equals to this identity. So this is going to be minus cos 2x, right? What do you know about minus cos 2x? Do you see the fact that that is exactly what, let's go back. That is exactly this. Do you see that? And we already found the range for that one, right? So we already found the range for that, right? We already found the range. So we know that the range for this, right, is what? So we know that the range for this is basically y is an element between what? Between -1 and 1. But y is the same as this, right? So I'm going to rewrite it. This is the same as saying negative cos 2x, right, is an element between -1. So that's where it exists. Because of y is the same as this function. It's the same as f of x. Hope I'm making sense, right? So with that said, is that this, and again, we can write it like this so that it can make simple sense. This is also the same as what? This is f of x, right? So this is the same as saying f of x is an element between -1 and 1. Reason why I'm writing it f of x, we know the fact that this is basically the same as 4 to the power what? To the power f of x. Do you see that? Then here is that we need to replace f of x by the largest number, right? Since we're looking for the maximum. So since, let me just write it here. Since we want the maximum, right? Therefore, we know that f of x is basically going to be equals to what? In our case, the maximum is 1. So here we're going to replace it by 1. Hope that makes sense. So that's going to be what? That's going to be 4. So it's going to be what? It's going to be the maximum value is equals to 4 to the power 1. So this is going to be basically equals to 4. So now we're going to do question 8. It says in the diagram, right, A, B, C lies in the same horizontal plane, right? So A, B, C lies on the same horizontal plane. And they tell us the fact that there's a vertical pole. So the vertical pole, which is DC, which is H, right? And has H unit. And they tell us the fact that AB has K units. So this one, then they tell us the fact that this angle is theta. So it's here. And this one is beta. Where is beta? It's going to be this one, right? So it's going to be this entire one, right? So that is BAD. So this whole thing. Then they tell us that alpha is equals to the small one, right? So with that is that the first question says determine the size of what? Of CDA. So let's find CDA. So C, where is C? Okay, so C is here, CDA. So we see the fact that we're looking for this one, right? We're looking for this angle, right? And it needs to be in terms of theta. So we see the fact that that whole thing is going to be give me a right angle triangle. So this whole thing gives me a right angle triangle, right? You see, because we have 90 here. So I can use what? I can use sum of angles in the triangle because I have theta here, I have 90, and I'm going to find this angle here. So now let's find that one. So it's going to be what? It's going to be angle, the one that they want. So it's going to be CDA plus, right, plus this angle, which is going to be theta. So it's going to be plus theta plus this angle here, which is 90. So it's going to be plus 90 is equals to 180 degrees, right? You don't need to write sum of angles in a triangle, but I'm going to write it so you guys know sum of angles in triangle, right? So now we know the fact that this is going to be, take everything to one side, so it's going to be CD A is equals to 180 minus 90 minus theta. So this is going to be CD A is going to be equals to 90 minus theta. So this angle here, right, is going to be 90 minus theta. Hope that makes it right. So that's how you would find that angle. So now we're going to do 8.2. It says find AD, right? So let me mark AD. So AD is this one, right? And they want it, very important, they want it in terms of what? They want it in terms of H and theta, right? So meaning I'm going to use this triangle again, right? So AD, we see the fact that it's the hypotenuse. So it's the hypotenuse, right? Because it's a right angle triangle. And this is going to be opposite. So you're going to say opposite over hypotenuse, which is sine, right? So meaning sine. So sine theta is equals to what? Is equals to H, which is opposite. Then hypotenuse is AD, what we want, right? So it's going to be AD multiplied by sine theta is equals to H. So now we're going to make AD the subject. So it's going to be AD is equals to H divided by what? Divided by sine theta. So now we're going to do 8.3, right? It says show that CD, so we're going to highlight that CD. So let me just pick green. CD, which is this one, can be written as this, right? So let's look at what they gave us so that we can like go backwards to find it, right? So we see the fact that CD, right, is H. We see the fact that's H, right? So from our answer, we see the fact that K needs to be there, alpha needs to be there, beta needs to be there, right? And also this theta needs to be there, right? We see that. Then we see the fact that from everything that we have, the triangle that makes sense is this triangle in terms of the angle wise, right? Is this triangle. Do you see? So this is the triangle that makes sense, right? So we see the fact that yes, CD is here, right? But do you see the fact that H is also here? So from this triangle that we highlighted, right? We can still find H, make H the subject. So do you see from this whole thing, right? We have everything that we want. We have H, which is here. We have theta, which is here, right? We have beta, we have everything that we need. So we're going to use that, right? So now using that is that we need to basically be able to have all the things that we need, right? So what I mean is the following, is that in terms of theta, in terms of our theta, right? In terms of our theta, we see the fact that our theta is somewhere here. So we can relax because we can use the side. Meaning beta and this one are going to go together. So if I do this, these two are going to go together. These two, let me just do it in red. These two are going to go together, right? So these two are going to go together, just like this, right? Then we see the fact that K needs a side. So meaning K needs to go with this one, right? So we know the fact that these two are going to go together and this going to go together. Then you're probably asking yourself is that, okay, if that's the case, we have covered the following, right? We have covered the fact that now we have theta and we also have K. We have alpha, and we have K. And now we have theta. But you see the fact that this angle, we can find it, right? Just looking at the green triangle, right? Is that we know what this angle is. We know what this angle is. And we can find the sum of angles in a triangle by finding just this one, right? And I'm just going to make it in green. We can find the angle, this one. We can find it, right? So that's going to be what? 180 minus the two angles, meaning minus alpha and minus beta, right? Which is going to be the same as saying 180, right? 180 minus open bracket, take out the negative. So it's going to be alpha plus beta. So do you see the fact that now we have everything that we need, right? This angle now covers our beta and alpha, which is good. Then we have our theta already covered here. So now we know the fact that with this pairing up, we're using sine rule, right? Because we're going to use sine rule here. So now using sine rule, we know the fact that it's going to be what? It's going to be, we can start with the trig ratio or the sine. So I'm going to just start with this one, right? So I'm going to say AD, right? Divided by what? By sine. So AD, right, remember matches up with this sine beta. So sine alpha is equals to what? Is equals to the side, which is AB, which matches up with this one, with this angle, right? So it's going to be sine. So it's going to be sine. The angle that we just found, it's going to be 180 minus alpha plus beta. Hope that makes sense, right? So we know the following. We know the fact that AB is K, right? So we know the fact that AD, I'm not going to substitute this one yet, right? I'm going to substitute it later on. And this is going to be sine alpha is equals to K. And this is going to be divided by, then we're going to use trig ratio. 180 minus is what is, let me just go back. 180 minus the angle. So 180 minus the angle. And it's sine, right? So let's go back in trig and reduction. So 180 minus, remember that 180 minus, so it's sine. Sine is positive, so let's go down now. So this is going to be positive. So this is going to be positive sine alpha plus beta, right? So now we're going to cross multiply, making AD the subject. So you know the fact that AD, right, is equals to what? Is equals to K multiplied by sine alpha. So what I did is that since this side, this one is multiplying, I took it to the other side. It's going to multiply this side since it's dividing, sorry. So it's going to be like that. Then this whole thing is going to be divided by sine. Then it's going to be alpha plus beta, right? So we have that. But we know the fact that AD, right? So we know the fact that AD is equals to this. So let's substitute that, right? So it's going to be H divided by sine theta is equals to K sine alpha divided by what? Divided by sine alpha plus beta, right? So we're going to make H the subject. So it's going to be H. So H is going to be equals to, take it this to the other side. Since it's dividing, it's going to multiply here. So it's going to be K multiplied by sine alpha multiplied by sine theta, right, is divided by what? Is divided by sine theta plus beta, by alpha plus beta. So we see the fact that that's exactly what we got here. So now we're going to do 8.4. It says calculate the length of the pole CD, which CD is the same as H, right, to the nearest meters. And they gave you that K is equals to 95 meters. Then they gave you theta, beta, and alpha. So we're going to just use this because it just has everything that we need. And we know that CD is H, right? So we know the fact that CD is H. So we're going to say H is equals to K multiplied by sine alpha multiplied by sine theta, and that whole thing is going to be divided by what? By sine, and that's going to be alpha plus beta. Let's substitute. So H is equals to 95, right? Then it's going to be multiplied by sine. What's alpha, right? It's going to be 32,7. Right, then it's going to be theta is going to be sine 43,9, right? And this whole thing is divided by what? Is divided by sine. Then open bracket, alpha is going to be 32,7. Then this is going to be plus beta is going to be 61, right? Then basically what you're going to do is that you're going to punch this whole thing into your calculator. Then your H is going to be equals to 35. 35,66, right? So it's gonna be 35,66, which is gonna round off to your height being what? Rounded up, it's gonna be 36 meters. So that's gonna be your height, your age, which is therefore the same as your CD, is equals to 36 meters. So now what we're going to do, we're going to do Euclidean geometry. So you know the first thing that we need to do is to fill in the diagram before answering the question. So now let's do that, right? So it says in the diagram, right, in the diagram below, they tell us the fact that CD is the diameter of the circle with the center O. So I'm going to highlight CD, right? So we see the fact that this is CD, right? They tell us the fact that that is a diameter. If that's a diameter and there's a point touching here and it creates a triangle like this, then we know the fact that this is what? This is 90 degrees. Know that this is 90 degrees, right? So since this is 90 degrees, we can find E1, because E1 is going to be what? It's going to be 90 minus x. So it's going to be 90 minus x, right? Because of this x, since it's 90 the total, we just subtracted to get E1. So that's E1, right? So now we need to just write the information here on the side, right? I'm just going to call it diameter and center. So it's going to be diameter, right, and center. So we know that the first thing is that E1 is equals to 90 degrees, right, minus x. And the reason for that is angles in a semicircle. So it's going to be angles in a semicircle, right? So we have that. Then we see the fact that since we're dealing with what? Since we have center, meaning we're going to have radius. Because from here, tangent and circumference, that's a radius. And also here to here, that's a radius, right? Meaning this is also what? This is equals to x. This is equals to x, right? That's equals to x. Then here, do you see the fact that we have a radius? This one is a radius. And also this one is a radius, meaning these two are equals to each other, right? Meaning this one is 90 minus x. So also this one is 90 minus x. So now let's fill that up, right? So we know the following. First, we need to state is that OD, we know the fact that OE, so OE is equals to what? To OC. And both of them is radii, right? Then we know the fact that angle C1 is equals to x. And reason is going to be what? Opposite angles, opposite sides equal, opposite angles equal. I'm just going to put the factors in isosceles, right? But remember, when we're answering, I'm going to just write the correct one. Then we have established the fact that C1 is what? Is x. Then we see the fact that again, that OD is equals to OE. And that's radii again. Then we know the fact that angle D is equals to 90 minus x, right? And that is going to be what? That is going to be isosceles triangle. Hope that makes sense, right? So that finishes up the first statement. So since it's red, I'm going to highlight this part in red because it matches up with our statement. Hope that makes sense. So now let's erase that, right? Now, continue with the statement, right? They tell us the fact that E is a point on the circle such that, so let me just zoom it. They tell us that E, right, is a point, right, in the circle such that DE is produced at G, right? So they just tell us the fact that it extends, right? And they tell us, they continue and tell us the fact that OE, right, OE, OG, CE are drawn. So they're just telling us which points are drawn. And finally, they tell us what? They tell us the fact that let this be equals to x, right? And this be equals to 90 degrees. So COG, right, equals to 90 degrees. So what's COG? So we see the fact that C OG. So this angle, so angle O1 is equals to 90 degrees. So let's do that, right? We know the fact that that is equals to 90. I'm just going to make it in black because that's a given information, right? So from that is that if that's equals to 90, do you see the fact that from that information, right? And I'm just going to make it in purple, right? If we look at this triangle, right? From the information that this is a 90 degrees, is that means the fact that this is also 90 degrees, right? So let me just put it in both sides. So also meaning this one is 90 degrees. If this is 90 and we have this angle because we already solved it, do you see the fact that we can solve that angle? So let's solve for that angle, right? So I'm just going to change my pen into purple, right? So the reason for that one is for that C, angle OG is equals to 90 degrees. So we're going to have information regarding that. And let me just move this up just like this, right? So we can solve for G2, right? So we're trying to fill up this entire diagram as much as we can with the given information, right? So now let's find C2, right? So from that is that we know the fact that angle, so we know that angle D plus angle G2, or let's start with G2 because that's what we're looking for. Yes. So we know the fact that angle G2 plus angle D plus, let's just name the one that they gave us, which is C. No, it's not C. Let's name this one. It's going to be DOG. So angle DOG. Right, DOG is equals to 180 degrees. And that is what? Sum of angles in a triangle, right? So sum of, I'm just going to put a triangle. Sum of angles in a triangle, right? Then we already know that angle D is 90 minus. So it's going to be G2 plus this is going to be 90 minus X, right? Then this is going to be plus what? Plus 90 degrees is equals to 180 degrees, right? So now let's solve for G2. So we know the fact that angle G2 plus this is going to be what? 90. So 90 and this 90 is going to give you 180. So it's going to be 180. Then it's going to be minus X is equals to 180 degrees. Then take everything to the other side and make G2 the subject. So G2 is equals to 180 minus 180, then plus X. Therefore, we see the fact that angle G2 is equals to what? Is equals to X. So we see the fact that this angle here is also equals to X, right? And this is from this statement. Hope that makes sense, right? Then circling back, we see the fact that from this one, right? Do you see from the finding that this is 90 minus, right? If I just draw, and I'm just going to emphasize it, I think let's go back to the red one because it falls under that one, right? Do you see the fact that in this triangle, we can use sum of angles in the triangle to find O3, right? We can use sum of angles in the triangles to find O3. So let's do that. So what I'm going to do is that I'm just going to move this one a bit here and fill in the information there, right? So we see the fact that since we know that angle D is equals to 90 minus and both of them are equals to D, then we can find this one, right? O3. So we see the fact that, let me go back to red, is that angle O3. So let me just do that. Angle O3 plus angle D, right? Plus angle E1 is equals to what? Is equals to 180 degrees. And that's going to be sum of angles in a triangle, right? So let's substitute. We see the fact that we're looking for O3, right? And this is going to be angle D. So it's going to be angle D. So it's going to be 90 minus X. Then this is going to be plus again 90 minus X is equals to 180, right? So angle O3 plus 180, then it's going to be minus 2X is equals to 180 degrees. Then take everything to the other side and make angle O3 the subject. So it's going to be angle O3 is equals to 180 minus 180 again plus 2x. So therefore angle O3 is equals to what? Is equals to 2x, right? So we see the fact that this is going to be 2x. And again, finding that 2x, we could have found it in angle at center twice the angle at circumference. You see the fact that if we have this 2, it's going to be angle at center is equals to twice the angle at circumference. So since this is x, this was going to be 2x. So you could have found it using that, right? So it's two ways. It could have been angle at center twice the angle of circumference, or sum of angles in a triangle. Hope that makes sense, Anne? Then now is that since we know the fact that this is this is 2x, right? Do you see the fact that I can find O2? O2 is equals to what? To 90 minus 2x. Because remember the fact that this is 90, right? And this is 2x. So to get this, we subtract this. So it's 90 minus 2x. So from there is that therefore O2 again. So therefore angle O2 is equals to 90 minus 2x, right? So we have, in terms of looking at the diagram, I feel like we have enough, right? We have filled it to its probably capacity, right? So now, let me just take this and just put it here, right? So now I think we have done filling it up, so we can go and answer the questions now. So now we're going to do 9.1. It says, prove that OCGE is a cyclic quad. So let's highlight what we need to prove, right? So where is O? So OC, right? G, right? E. So this, the one that I'm highlighting, is a cyclic quad. So to prove a cyclic quad, you have a couple of things, right? You need to prove the fact that exterior angles, it's either, so you have three conditions that you can approach it. It's either you prove the fact that exterior, right? Exterior angles of a cyclic quad are equal. So meaning if we do this, do you see the fact that here we have exterior? So meaning we prove the fact that this angle A3, right, which is 2x, is equals to the opposite, right? If we have this one as being x, then we can prove that, right? Then another way is that we need to prove that what you call as opposite angles of a cyclic quad at up to 90 degrees. So meaning if here we have 90 degrees and we have 90, like if you have here this and this, they need to add up to 90 degrees. Then lastly is that we can prove that angles in the same segment. We see the fact that the one that we have here is angles in the same segment, right? Because if I draw a butterfly here like this, right, is that we see the fact that there's two are both equals to x, right? And with like angles in the same segment is that their reference point is O and E, and when we connect, we see the fact that we can connect to G2, which is x, and also when we connect to C1 is also x. So these two are equals to each other and they're both equals to x. So we're going to use what? Angles in the same segment to prove this. So now what we're going to do is that we're going to go back to the diagram and see how did we get C1 to being x and also G1 being x. So C1 is quite simple. We're going to deal with C1. How do we get it to be x? We see the fact that it's here, right? And for it to be x, it's going to be this 2, right? So it's going to be this 2. So we know the fact that that's how we got C1 to be x. So we're going to start with saying what? From here, we know the fact that this and this are radii, and this one is equals to x, right? So it's going to be what? We start with the radii, right? So we know the fact that OC is equals to what? Is equals to OE, and our reason is radius. The reason why we need that, right, is that that is how we know opposite angles equals, right? What you call this, opposite angles equals, meaning opposite sides equals, opposite angles equals. Hope that makes sense. So now we can conclude that C1 is equals to also x, right? And our reason is going to be what? Opposite sides equals, meaning opposite angles equals. Right? So we're done with C1. Right, now let's move to G2. If we go back to the diagram, right, G2 is here. for us to conclude that is equals to x is that it was sum of angles in the triangle, but we had this angle was given as being 90, right? Then we have D, then D we know the fact that is this. But when we go back to D, D is equals to this because of isosceles and also because of radii. But before that, how did we get the fact that it's 90 minus? It was because E1, right? E1 is equals to 90 minus. Hope that makes sense. So our statements needs to start here, right? Then from here is that we need to go from here. So I'm going to take it off. So it's going to be start from here. Then from there is that we need to establish the, what you call this, the radii. Then come here, right? Then say sum of angles in a triangle, right? Then after saying sum of angles in a triangle, then conclude that is equals to x. Hope that makes sense, right? So now let's do that, right? So we need to start with what? With angles in the semicircle. So we're going to say what? Angle E1, right, is equals to 90 minus x, and that's going to be angles in semicircle. Right? Then now we're going to move to what? We're going to move to the next one, which is going to be what? We know the fact that OD, so we move to radius. That's how we got D to be 90 minus, right? So it's going to be what? It's going to be angle D. No, radius first. So it's going to be OD is equals to OE, and that's radii. Then we're going to move to angle D. Angle D is equals to 90 minus x, right? So that's going to be what? Going to take this reasoning. Cut. So let's delete this. Yes. Paste. Yes, because it's the same reason, right? Then we know the fact that now we're looking for sum of angles in a triangle of this triangle, right? So that was what? That was angle. So we know the fact that that is going to be angle. Let's state that this is 90 degrees. That's given. So we're going to say angle D O G is equals to 90 degrees. And that's given, right? Then now we know the fact that sum of angles in a triangle, so it's going to be what? Angle G2, right, plus angle D OG, right, plus angle what? So plus angle, so it's angle D, angle GOD, so it's G2O plus angle D. Sorry, yes, plus angle D. Forgot angle D, and that's going to be equals to 80 degrees, 180 degrees, and that's going to be sum of angles in a triangle, sum of angles in triangle, right? Then after that is that we can just conclude that angle G2, right, is equals to x. You don't need to solve it because we already solved it. Then you can conclude that that's equals to x. Right, since now we know the fact that both of them are equal, so therefore angle C1 is equals to angle G2, right? Therefore you conclude that what they want, which is OC, OCGE, is a cyclic quad, is a cyclic quad. And our reason is going to be what? Angles in the same segment. Angles in the same sec. So now we're going to do 9.2, right? It says name with reasons 3 other angles that are equals to x. So we know the fact that from the diagram we have this being equals to x, and we also have this one equals to x, right? So we need one more. But remember the fact that in the previous question is that we proved that this is a cyclic quad, right? So since this is a cyclic quad, right, do you see the fact that this and this are also equals to x? And I'm just going to demonstrate it. The reference point is going to be C and O, and both of them, C and O, can connect to G1, right, and also connect to E2, right? And E2 is x, so meaning this one is x. That's a cyclic quad. So we can just have this as being equals to what? 2x, right? It's as updating the diagram. So now with that is that let's write, right? We know the fact that angle C1. So we know the fact that angle C1 is equals to x, and you can say the fact that it's proven because it is proven, you proved it, right? Then also we know that J2 is also equals to x, and that's also proven from the previous question, right? Then lastly, angle G1, right, is equals to x, and that's going to be what? Angles in the same segment. Angles in the same segment. So now we're going to do question 9.3. It says determine the size of D. Where's D? So it's D OE. So this angle, we already know the fact that that is equals to 2x, right? And the reason why it's equals to 2x, remember I said the fact that when we were doing it, we said the sum of angles in a triangle. That's how we arrived the fact that that is O3 is equals to 2x. But I told you the fact that another way is what? Angles in the same segment. What you call is angle at center twice the angle at circumference. So let's use that one because I feel like it's the easiest one, right? So now we know the fact that angle ODOE, right? So what they want is going to be DOE. Angle DOE is equals to 2x, right? And I'm going to use angle at center twice the angle at circumference. Angle at center is equals to 2 times angle at, so angle at circum. And that's it, right? As I said, the fact that you see, this is our reference. It goes to center, then it goes to circumference. So we know the fact that this is x, so this is 2x. Or you can just use sum of angles in the triangle of this one. Doesn't matter, but I just used the easiest one. Hope that makes sense, Anna. So now we're going to do 10.2, right? So with 10.1, it's a proof. Again, I'm not going to do the proof inside the description. I'll just link the proof from my master Euclidean video. So it's already done that. It's just repetition. So I'm not going to just redo it again. So let's do question 10.2, right? So 10.2, it says in the diagram, A, C, and F are points on the semicircle, right, with center B. So we see the fact that this is like the semicircle, right? And we have a diameter on the big circle, which is the semicircle. So since we have that, I'm just going to mark it, right? So we're going to mark it. Then we see the fact that we have a point F, and that point is touching the circumference of the half circle. So it's like this. So let me just do this. Since we know the fact that this is a diameter, right? So meaning this is equals to 90 degrees. So we know the fact that this is going to be equals to 90 degrees. Right? So let's write that, right? So it's going to be diameter. I'm going to name it. So it's going to be diameter AC. And we see the fact that angle F2 is equals to 90 degrees. And our reason is semicircle. So now looking at it, right? So let me just close this. So now looking at this, this is the only theorem that I can like fill in, right? So there's nothing much. It's just that, right? So that's the only thing that we have. So now let me just delete this and highlight this part. Yes, referring to the diameter, right? Then it continues, it says a circle, right? A is a circle with center C, so that's this circle, right, is drawn. So we see the fact that center C from the small one is drawn, right? Is drawn. And when we see it, we see the fact that there isn't any like alphabet here. So the lines extend. So I can't say the fact that this and this are equal because of there isn't any alphabet here. So this whole line, we just need to focus on that. We focus where the alphabets are. Hope that makes sense, right? So me having C as the center doesn't give me much, but I know the fact that, okay, cool, this is happening, right? So it tells me it's drawn. Then they tell us the fact that the radius of the semicircle is twice. Very important. So we have this information, and I'm just going to fill it in the diagram. Maybe let's make it, yeah, let's make it green, right? They tell us the fact that the radius of the semicircle is 2 times the radius of C. So meaning this radius, do you see the fact that the radius of this circle, if this is equals to x, right, then the radius of the semicircle, this is going to be 2x. Hope that makes sense, right? So now let's fill that in. So we know the fact that if this is going to be, I'm going to use where there is actually a radius, right? Do you see this is a radius? I'm going to name it x, right? And this is going to be what? Meaning this is going to be 2x. And this whole line here, from here to here, because that's the radius of the semicircle, do you see? Right? That's also going to be 2x. Hope that makes sense, right? Hope that makes sense. I'm naming this one x because that's the one that has an alphabet that shows me the radius. Hope I'm making sense. So that is that. They tell us that. And then the thingy continues and says what? And says FED. So FED, so it's FED is a tangent on both circles at F and E respectively. So let's start with this one, right? Let's start with this one. So we see the fact that if that's a radius, no, sorry, a tangent. So let's make it blue. So we see the fact that if that's the tangent, we're gonna have this, right? And we have a point here in the circumference, here in the circumference, and also here in the circumference, meaning this angle here is equals to this one, right? So we see the fact that tangent, I'm going to just make notes and say tangent, right? So let me just do this, yes, tangent. So we see the fact that angle F1 is equals to what? Is equals to angle C1, and that's 10 chord. Right? So we sorted that one. So now let's go the opposite way. So we see the fact that if we have a tangent this side now, on the semicircle, we have a point here, we have a point there, and we have a point there. So now I'm just going to change my color, maybe into dark blue. This one and this one are equals to each other. So we see that F3 is equals to angle what? CAF, and the reason is 10 chord. Right? So we sorted with that one. So let me just erase this. Now we're going to look at the small circle, right? So we see the fact that from the small circle is that we don't have 10 chord, but we have what? This E2 and E1 is 90 degrees because that's 10 chord. So we know the fact that that's going to be what? No, I don't want it in green because we already used green. So purple. So we see the fact that angle, so we know the fact that angle E1 is equals to angle E2, which is equals to 90 degrees, and S10 perpendicular to radius. Right? So that's what we have. So with that, our diagram is filled. We can't fill it more. That's what we have, right? So that's what we have so far. So now we're going to do the first question, which is 10.2.1. It says, prove that triangle AFC is similar to triangle FEC. So let's find that. So I'm going to highlight them, right? So I'm just going to highlight one in yellow and the other one with another color. We'll see. So AF, so it's going to be AF, right? AFC. So this triangle, right? We need to prove that it's similar to which triangle? FE. So it's FE, FEC. So this triangle. So just looking at it, we need to see what can we prove, right? So we just need two statements. You genuinely need two statements, two angles to be equals to each other. Then the last one, because in total you need three statements, right? You just need two statements if you're using angles. Two statements to be, you find two statements of angles that are equals to each other. Then the last angle, right, is going to be like sum of angles in a triangle. So we see two angles, this and this, are equal, right, because they both dark blue. Then we see the fact that this is a 90 degrees, right, and also this is a 90 degrees. So second one, meaning C1 is going to be automatically equals to C2, and that's going to be sum of angles in a triangle. So as I said, the fact that you only need two angles to be equal, you found them. Then the other one is just conclusion, the fact that there's sum of angles in the triangle. So we're going to say in, so you're going to say in, sorry, like, so you're going to say in triangle AFC and triangle FEC, right? So the first statement, the easiest one is this one because that's 10 chord, right? So that's 10 chord. So you're going to say angle CAF is equals to F3, and our reason is going to be 10 chord. It's going to be 10 chord theorem, right? Then the second statement, which is this one. So this one, we know the fact that it's E1. We know the fact that E1, you need to state it first. You know the fact that E1 is equals to 90 degrees. And the reason is 10 perpendicular to radius. Right? Then we know the fact that this one is angles in a semicircle. So we know the fact that angle F2 is equals to 90 degrees. It's angles in a semicircle. Right? So therefore we know the fact that angle E1 is equals to angle F2. Then the last statement, right? What do we left here? We left with C2. So you left with C2, which is equals to what? On the other side, C2 is equals to C1, right? So C2 is equals to C1. And that's going to be what? That's going to be sum of angles in a triangle. Sum of angles in a triangle, right? So now you can conclude that triangle AFC, right, is similar to triangle FEC, and the reason is going to be angle, angle, angle. Hope that makes sense. So now we're going to do what? We're going to do 10.2.2. It says if the radius of the smaller circle is P, so we know the fact that we named it as what? We named it as X, right? Then they tell us the fact that determine the following in terms of P. So basically this X, I'm going to replace it as P. So let's do that. Maybe let me just take my white. Just want to change this into what? Into being P. So let's do that. Yeah. So go back to black. So we know the fact that this is P, meaning this is going to be 2P, and this is going to be 2P. Hope that makes sense, right? So now what are we determining in terms of P? It's going to be the line FE. So FC. So FC, this line. So the line in blue is the one that we're determining to be in terms of P. So what do we see? We see two things, right? We see the fact that this triangle, do you see that this triangle, right? And also this triangle, right? What share the side as being common. But the nice part is that we already established that this F3 is equals to this angle, right? And also we know the fact that both of them are equals to 90. So this is like a right angle triangle, meaning I can use trig ratios, right, to solve it. So if I say Remember the fact that I'm looking for it to be in terms of P. So I know the fact that, let me just, before we even go there, right? We know that the entire side, this whole side, right, is basically equals to 4P, because it's 2P plus 2P, right? So I know the fact that I can write a trig ratio where it's going to be in terms of P and the side that they want. And also I know the fact that I can write this, on this other one, I can write it in terms of the side that they want, and also in terms of P, right? And since they both equals to 90 degrees, I know the fact that since these two angles are equals to each other, meaning whatever the trig ratio it is, right, is that I can share them. Like it's going to be equals to each other. Hope that makes sense, right? So I'm just going to write a couple of notes when explaining this, right? So we know the following, right? We know, right? We know that, or we see that, we do not know, we see that. we see that CF, or what they're looking for, FC, let me just call it how they're looking at it, FC. So we see that FC, right? FC is what? We see that FC is common, right? It's common in both the triangles. So I'm going to name it. So it's going to be this triangle and also this triangle. They share a common side, right? Is common in triangle, triangle CEF, and triangle ACF, right? So we see that, right? And also we see the fact that that side is common from both of them, and also we know the following, and also angle F3 is equals to this angle, right? So it's equals to this angle, which is, I'm going to name it as FAC. So it's FAC, right? And the reason for that is what? Is 10 chord. It's 10 chord theorem. We already proved that, so you can say proven. 10 chord theorem. So we have that part, right? So if that's the case, is that I'm going to write each one of them in terms of what? In terms of the trig ratio, right? So we also know the fact that both triangles are what? Are 90 degrees, meaning it's a right angle triangle, right? And we have established the fact that this is 90. So we established the fact that, let me go back, that both of them are equals to 90. So we don't need to say. So the thing that I'm going to say is that this is 90 and this is 90, so that it established the fact that it's a right angle triangle, right? We also know the fact that angle E1 is equals to 90 degrees, right? So you can say 10 chord theorem, 10 perpendicular to radius. Then the other one, which is angle F2, right, is equals to what? Is equals to 90 degrees. And you can say the fact that this is proven. Or you can just write the reason again. Hope that makes sense, right? So therefore, triangle CEF and triangle ACF are right angles triangles. Are right angle triangles. Hope that makes sense, right? So now with that is that I'm gonna write this one, the side that they want in terms of P. So we see the fact that from this angle that we both know the fact that it's equals to each other, it's going to be opposite, then hypotenuse is going to be the side that we want, which is FC, right? So in triangle, so that's this triangle, so it's going to be triangle CEF. So in triangle CEF, right, we have the following. We have the fact that sine F3 is equals to opposite, which is going to be P, divided by FC, what they want, right? Then in triangle, so in triangle the other triangle, which is the bigger one, which is A, triangle ACF, right? So we see the fact that that's going to be what? We want the side that we want plus the one that has P. So that's opposite, right, over hypotenuse. So it's going to be sine. So we see the fact that that's sine A. So that's going to be sine, what's that angle? So it's going to be sine F AC, right, is equals to what? Is equals to opposite is going to be FC divided by what? Divided by 4P. But we know the fact that angle F3 is equals to angle AC. So therefore, those two are equals to each other. Therefore, we see the fact that sine F3 is basically equals to sine FAC, right? So if those two are equals to each other, then we can equate those two. So let's equate them. So that means the fact that P divided by FC is basically equals to FC divided by 4P. Cross multiply. So meaning this and this are going to multiply and this are going to multiply. So we're going to have 4P squared and we're going to have FC squared. Square root both sides. So it's going to be 4P squared is equals to square root FFC squared. So thus we're going to be left with 2P and here's going to be FC. So therefore FC is basically equals to 2P. So that's how you would solve this question. So now we're going to do B, right? It says the length of FD, right? So FD is going to be this one. So let me just highlight that one. So we're looking for this one. So let's make it in yellow. So we know the fact that we're looking for the yellow one, right? FD. And we already solved the fact that FC is equals to 2P. So let's put that in the diagram. So we know the fact that this is 2P, right? So we're looking for what? For FD, right? If they tell us the fact that if FE is equals to ED, so those two are equals to each other. So what we're going to emphasize is we're going to emphasize on this triangle, right? Because we see the fact that since this is a right angle triangle, we can use theorem of Pythagoras. Because of this and this, we have it. So using theorem of Pythagoras, we can find that. And we know the fact that this one is twice of this. Hope that makes sense, right? So that's what we're going to do. So now using theorem of Pythagoras, we know the fact that what? We know the fact that we're going to start with the hypotenuse because the hypotenuse is equals to the sum of those two, right? So it's going to be FC. So go back to black. So it's going to be FC. So it's FC squared is equals to what? Is equals to CE squared, right? Plus what? Plus FE squared. And just so that you guys are not confused, let me just do this. Let's reference in which triangle. So in triangle, I want to just keep CEF, so CEF. Is it CEF? Let me just check. CEF, yes, it's the correct triangle. CEF, right? And the reason for this one is going to be what? Pythagoras, right? So the reason for this is going to be Pythagoras. Pythagoras. Right? So now let's substitute. We see that FC is equals to 2P. So it's going to be 2P squared. And CE is equals to P squared plus FE. That's what we're looking for. So this is going to be 4P squared, right? And this is going to be equals to P squared plus FE. So now we're going to take the P squared to the other side. So this is going to give me 4P squared minus P squared is equals to FE squared. So this is going to give me 3P squared is equals to FE squared. Square root both sides. So it's going to be the square root of 3P squared is equals to the square root of FE squared, right? So this is going to give me what? This is going to give me P square root of 3 is equals to FE. But, right, from the question, we know the fact that FE is equals to ED. So therefore, our FD is equals to FE plus ED, right? So therefore, that is the same as, since they're both equal, so FD is basically equals to FE, right, plus another FE, which FD is basically equals to 2FE. Hope that makes sense. So now substituting FE, because we have that, so it's going to be FD is equals to 2, then open bracket is going to be P square root of 3, right? So FD basically is equals to 2P square root of 3. So now we're going to do question 11, right? It says in the diagram below, a cyclic quad, right? And they tell us that's EFGH. So let's highlight that so we can put the properties. So it's going to be EF, right? So let me just do it properly. So we see the fact that it's EF, right? G. So here, then we have this and this. So that's our cyclic quad, right? So let's look at the properties. So first we need to look at, do we have angle in the same segment? No, we don't, because we don't have this bow. So we do not have that, right? Then the next thing is that we can't say opposite angles of a cyclic quad are equals to 180 because we don't have actual numbers. So the one that's closest that we can use is this one, exterior angles. So we see the fact that we can extend this. So meaning this angle here is equals to this angle. Do you see? Then if we extend on the other side here, we see again the fact that with a different color, that this angle here is equals to this one, that's exterior angles of a cyclic quad. So now let's fill that in, right? So I'm just going to highlight this in red. So the fact that this is a cyclic quad, right? And we're going to just write the information. So I'm going to say cyclic quad. So we know the following. We know the fact that angle, I'm going to do it in green. So angle H1 is equals to angle F. And that's exterior angles of a cyclic. Let's just end it there. Then we see that angle G1 is equals to angle E. And the reason is going to be the same. So this is going to be in purple, consistency. So it's going to be angle G1 is equals to angle E. And the reason is going to be the same as this one, right? So when looking at this being a cyclic quad, we see the fact that that is the only two things that we can take out from it, right? So now let's continue reading the statement, right? So let me just erase this. Okay. So now continue reading the statement. It says chord CE. So we see the fact that we have a chord CE, right? Chord EH, right? And chord FG. They tell us the fact that they extend to create this. So it doesn't tell us anything. It's telling us the fact that it's extending, right, to meet K. And they tell us the fact that what? They tell us the fact that M, M is a point on where is M? So M is a point on this line, which is EF, such that then they tell us this too. So now let's look at parallel lines. We're going to highlight them, right? So the parallel lines that they give us is MG and also EF. So it's going to be this one, right? So we see the fact that if it's this, we extend the parallel lines, meaning the entire line is parallel. Even though that they said this portion, which is going, what you call this, EK, or they told us the whole thing, sorry. So I thought they told us this. So it means the whole thing. So what do we see? We see the fact that from this being parallel lines, we can create an F, right? So we can create an F, meaning this, right? So meaning, do you see the angle that's purple? Meaning this angle here is also going to be purple. Because do you see, from the F, this and this are equal. So meaning this is going to be also purple. So from here, let me just highlight this. Just looking at this, right? So this is going to be what? This is going to be MG, right? Is parallel to what? To EK. Underline that. Good. Right? So we see the fact that angle M1 is equals to angle E. And that is going to be F. I'm just going to put in F. Corresponding angles. Right? So we see that. Then we see the fact that if I erase this and look at corresponding angles from the other side, which is going to be this side. Do you see here? It creates another F. So meaning this angle, which we're going to make it another color. So we have green. So let's make it red. This angle here is basically equals to this angle. And that's F, right? So we see the fact that angle K, right? It's, yeah, angle K is equals to angle G, G3. And that is Z. Right? So that's going to be Z. Alternative angles, right? Then when we continue again is that, do you see the fact that we can create, no, that's F. I'm sorry. This is F. So this is going to be F again, right? Then when we continue, right, is that, do you see the fact that we can create a Z? This creates a Z, do you see? Going from this to this to this. So meaning these two are equals to each other, and that's it. Right? So since this is green, do you see the fact that this is green, meaning this is green again? So now let's go back to green. So meaning this is green. So now we know that angle H1 is equals to angle G2. And that is going to be our Z. Hope that makes sense, right? So now we see the fact that in terms of statements wise, in terms of what you call this, parallel lines, we're done with that, right? Then we're gonna do the last statement, which is, and they tell us the fact that KG, so KG, right, is equals to EF. So EF is this one. So let's highlight them just to emphasize it when we're answering questions, the fact that we know the fact that those two are equals to each other. So we know that this one is equals to EF, so it's going to be this line. So we know the fact that the ones that are in green are equals to each other. So what I'm going to do is that I'm just going to put them like this, just to know the fact that those two are equals to each other. Hope that makes sense, honey. So now we're going to do question 11.1.1. So it says we need to prove that EF squared, right, is equals to what? Is equals to KE, right, multiplied by GH. So the minute you see any questions that are dealing with ratios or things like this, is two ways to answer them, right? It's either you're going to use parallel lines, right, or you're going to use similarity, like proving that two triangles are similar, then from proving that two triangles are similar, finding the sides. But to establish which one you need to use is that we need to basically mark off the sides, right, and see which one we have to pick, right? So let's mark it, right? So I'm going to mark them in red, right? So we see the fact that it's EF, so it's going to be EF, so it's this side, right? EF, then KE, KE, right? So it's going to be this side, right? KE and G and G and GH. So it's going to be GH. So it's this side. So we see the fact that, okay, cool. These are the three sides. So I need to have these three sides in my answer, right? When finding the ratio, I need to have that. Then we see the fact that, okay, cool, we have parallel lines. And then with parallel lines, this is the triangle that we're going to be dealing with. We're testing first, right? So we see the fact that this is the triangle, what you call this, the triangle that we're dealing with if it's parallel lines. So we see the fact that this is our problem. Do you see the fact that this line is our problem if we're going to be just dealing with this triangle? Maybe let me just emphasize it with the blue. If we're just looking at this triangle, right? The ones with parallel lines. So this one, right? We see the fact that, okay, we have this side, which is perfect, right? We have this side, but the problem is that in terms of ratios, the base, do you see the fact that KE is the base of the triangle. We can't have the base being the ratio. So this and this can't be a ratio. So this is our first red flag. And another one is this one. How do we connect it back to this? So we cannot use parallel lines, meaning the easiest way to solve this one will be what? Will be, let me just go back. Yes, because I've erased. I just want to erase this. Right? So going back is that since this is a red flag and this is a red flag, right? And only this one is connected to it, is that we need to find two triangles that we can prove that has this, this, and this, right? And we see the fact that we can form two triangles. The first one is that you see from the small one, from the small base, is that we can form this as being a triangle, because it's going to contain our base this, and we can form this big one as being a triangle too, because it's going to have this side and this side. Then we need to prove similarities of those two triangles. So the first triangle is going to be this one, right? And the second one, which is, I'm going to make it in yellow, is going to be this big one. It's going to be this big one. So we're going to prove similarities with this. And this is nice because remember when we filled in the diagram, we can see the fact that we can prove we need two angles. We need to find two angles, that the last one is going to be the sum of angles in a triangle. And we see the fact that K is common. So we have one angle. So we need to connect these two triangles with another extra angle. So we see the fact that from both triangles that K is common, right? So we have K, then we need another set. We see the fact that from the blue triangle, right? We see the fact that H1 is actually equals to angle F, right? And that's good. So we have another set of angles that are equals to each other. And that is what exterior angles. Then by default, this one is going to be equals to this one. And that is going to be sum of angles in a triangle. So we have already proved by just looking at it, right? So now let's write it. So for step one, we're going to prove that the blue triangle is similar to the yellow triangle. That is step one. Then two is that we're going to do the ratios implementing this, right? Then we're going to get this. Hope that makes sense, right? So now let's do that. So we know the fact that in triangle. So now even calling the triangle is very important how you call in the triangle. We know the fact that these two are equal. This is common. So it's going to be K. And we know the fact that these two are equal. So when you call it, if you're going to start with this blue triangle, if you say KHG, right, is that you need to match it up with the angles that are equal. So it's going to be, the second one is going to be KF, because of, remember you said H, and this is going to be E. So let's say that. So we start with the blue triangle. So you're going to say in triangle, then it's going to be KHG, right? And we start with the angle that matches. We know K is equals to K and H is equals to F, right? FE, right? So now we're going to start our first statement. We know the fact that angle K is common. Number two, we know the fact that angle H1, is equals to angle F. And that's exterior angles of a triangle. Exterior angles of a cyclic quad. Then lastly, it's going to be angle G1 that's left. So it's going to be angle G1 is equals to angle E. And our reason is going to be sum of angles in a triangle. Sum of angles in a triangle. So it's going to be sum of angles in a triangle. Hope that makes sense, right? So now, therefore, we can conclude that those two triangles are similar. So triangle KHG is similar to triangle KFE. And the reason is going to be angle, right? So that we have that. Then what I like doing when dealing with similarities of a triangle, when I'm finding the ratio, I like pulling them out, right? So I'm going to just pull them out. It makes it easy for me to match up what I need, right? So pulling them out, so I'm going to do the small triangle first. Then pull out the big one. And just for consistency, let's do this. We know the fact that this one is the blue one, and we know that this one is the yellow one, right? So we know the fact that this is going to be KH, right? KHG. Then this is going to be KFE. So we know that these two angles are equal to each other. Then we know the fact that H1, going to put in dots here, right, is equals to angle F. Then lastly, we know the fact that this is equals to this, right? So I'm going to highlight again what we need. So in our triangles, we're going to mark off what they want, right? Remember the fact that in the big triangle, we need KE. So we're going to highlight KE in red. So KE is going to be this side, right? Then also in the big triangle is what is EF. So EF, so it's the base. So it's going to be this one, right? And in the small triangle is what is HG, which is going to be the base, which is this side, right? So now when dealing with ratios, remember the fact that we need this and this, right? We see the fact that this side, right, since it's a tick and a dot, matches up with the angles that are on the side, meaning it's going to match up with this and this. So meaning the ratio, if it's this divided by this, is going to be equals to the one that matches up, which is going to be this divided by this one, right? Because this one we need, and this one matches up exactly with this one. So we see the fact that it's what? It's going to be KE. So it's going to be KE, right? Divided by what? By F, by FE. Then you need to match it exactly with those sides, right? And the side that we're going to match it up, we know the fact that we also need this side, and I'm just going to make it in yellow, right? Because of that side, even though they didn't give us in the question in terms of how we're looking for it, we know the fact that we need to match it up. So that 2 is equals to what? So this is going to be equals to KG, right? Because KE and KG, and this one's going to be equals to HG, right? So we're going to cross multiply. We see the fact that KE, right, multiplied by HG is equals to what? To KG multiplied by FE. So we go back to what they want, right? And I'm just going to put it here in red. So we know the fact that we need FG squared is equals to KE, right, multiplied by GH. So let me just enlarge that, and I'm going to put it in red, right? So that's what we're looking for, right? So now let's match up everything. We see the fact that we have what? We have KE, right? So I'm just going to highlight it. We see the fact that we have KE, right? We have it here, and we have HG, which is GH, which this and this is the same, right? So we have that. Then we have on the other side, we have EF, which is FE. So we have one of them, but we do not have KG. So first, so that to keep consistency, let me write it the way they wrote it. So we see the fact that we have EF, which is the same as KE, right? EF and KG, right? Then that's going to be equals to KE multiplied by what? By HG. So the problem is this one. But we know something. Remember when we were answering questions, I even put in the diagram, right? Is that we know the fact that these two are equals to each other. But we know the fact that KG is equals to EF, right? But we know the fact that KG is equals to EF. So therefore, right, is that EF multiplied by another EF is basically equals to KE multiplied by HG. So this is going to be EF squared is equals to KE multiplied by HG. So that's how you would prove this question. So now we're going to do 11.1.2. So is that, as I said, the fact that when you're dealing with this type of questions, right, it's going to be either two ways: the parallel lines, which is the big triangle, right, with the parallel lines, or it's going to be similarities. But we do not know till we highlight the parts that we need, right? So now let's highlight them. So we're going to take the red highlighter. Then we're looking for KG. So we see the fact that KG is this line, right? KG. And we also need what? We need EM. So EM is going to be this one, right? Then we also need what? We need KG, what you call this, KF. So KF, so we see the fact that way is K, so KF is going to be KF, so it's going to be from here till here, right? And we see the fact that from here, we actually can use this big triangle with parallel lines. So let me just highlight that triangle so that you guys can see, right? So if we take this triangle with parallel lines, right, we see the following. We see the fact that one, the base is not included in our answer, which is a good thing, right? So the base is not included, and also this is not included. And we see the fact that the sides that they're talking about is the sides of the proportionality theorem. Because of this, it's a side, why? Do you see the side that's divided by this parallel line? And also this side is the one that's divided by the parallel line, and also this one is the whole side. So what do we know? We know the fact that we need to match up things, right? We see the fact that this one matches up exactly with this one. This and this matches up with that one in terms of proportionality. Then we need the big side, which is KF, and we know that KF needs to match up with this big side. So we're going to put it in yellow. So it needs to match up with this one so that we can create the ratio, right? So we're going to take what we have. So it's going to be K. It's going to be what? It's going to be kg. So we know the fact that it's going to be kg, right? Kg, right? Which is this side, right? Kg divided by IKF, which, so divided by KF, right? That is going to be equals to what? Kg, which is this one, matches up with this one, which is going to be EM, right? EM divided by, then we know the fact that KF matches up with this one, the one that we highlighted in yellow. So it's going to be what? It's going to be EF, right? And your reason is going to be what? Proportionality theorem. And for habit's sake, write your parallel lines. So we know the fact that what? MG is parallel to EK. EK. So now we can cross multiply. We know the fact that KG multiplied by EF is equals to EM multiplied by KF. Then we see the nice thing. We see the fact that we have this whole side that's perfect. The problem is this. But remember the fact that when we were answering, we know the following. We know the fact that these two are equals to each other. We know that these two are equals to each other, right? So we know the fact that what? We know, but we know the fact that KG is equals to EF. So therefore, we have KG plus another KG is equals to EM multiplied by KF, right? So this is going to be the same as KG squared is equals to EM multiplied by KF. So now we're going to do what? We're going to do 11.2. So it says if it is given that KE, so we're going to put it down, right? So I'm going to put them in red, right? If KE, so KE is this whole side. If they say KE is equals to 20, so we know the fact that that is equals to 20 units, right? And they tell us that KF, so KF, so it's on the other side. So KF, this whole one, right? KF is equals to 16, all right? And they tell us the fact that GH, so GH is this one, is equals to 4, right? Then they want us to calculate what? They want us to calculate GH. So GH, so what they want us to calculate, I'm just going to put it in this orange. So they want us to calculate EM, sorry. So they want us to calculate this. Maybe let's just do it like this. This is what they want us to calculate, right? So now we see the fact that from what they given us information-wise, they gave us information from the similarities of a triangle. Do you see? The ratios that we can use is from the similarities of those triangle. Because of this is a problem and this is the problem in terms of ratio-wise. So we know the fact that to solve this, right, what we're going to do is the following. So look at this, right, is that from what we have is that we need this, right? But in terms of that, this comes from this triangle. Do you see the triangle of the parallel lines? It comes from a triangle of the parallel lines. But the nice thing is that if we find this whole side, right, is that this whole side by default is going to be, we're going to find this one. Meaning we can use what? We can use the parallel lines basically because of we have a full side here. And by default, after solving this one, we're going to have the full side. And this two, we're going to equate them together. Then we're going to find basically what EM is. But to find EM, we need to use the triangle, the similarity triangle, to find this whole side. Then after that, we can circle back on finding EM. Hope that makes sense, right? So let's do that, right? So step number one is to find what? We're finding. So step number one, finding EF, right? So finding EF, right? So finding EF is that we can use this. Do you remember the fact that when we proved this, right? Remember when we were proving this? Oh, and I forgot to put a reason here. Let me just, because triangle KHG is similar to triangle KFE. Yes. So we're going to use this, and you'll see why I'm going to be using this. So duplicate and cut. So that's going to be our first reason, right? And I'm not going to just bring back the triangles, or maybe let me just bring them back down so that you guys can see. So I'm going to take those two triangles, duplicate it, so I can show you why it's using the same thing, right? So put them. We do not need this part. Let me put this up. Yes. Okay, so now let's fill it up in terms of the unit so that you can see why we're using the same thing, right? So they gave us that KE, right? So KE is 20. So they gave us that this is 20, right? And they also gave us the fact that KF, which is this one, it's 16, right? Then they told us the fact that this one is what? They told us the fact that this one is 4, right? Then, as I said, the fact that our goal is to find what? Our goal in our case, right, is to find what? Our goal is to find this one, right? That's our goal, is to find this one. So that's what we're looking for from this triangle, right? So to find that one, do you see the fact that the one that we want matches up with this one? Then the side that I'm going to use, the other one is going to be KE and this one, right? Reason why, right? We know already the fact that those two sides are equals to each other. So that is why I'm saying the fact that we want the side that's equals to this one because of it's going to reduce things. And also that side is this one, not the other one that we were given. Hope that makes sense why we didn't use 16, but we used the 20. Because we know the fact that we're looking for this one, right? But with this one is that we also know the fact that these two are equals to each other. So on the other triangle, we have this, but to match it up with something that we use is this one. So that's why we're using the 20. And that is exactly this ratio. Do you see? KE is there divided by FE, which is what we want, is equals to KG, which is what we want because we know the fact that these two are equal, right? And this is going to be equals to that. Hope that makes sense, right? So we already know the fact that this is what? We already know the fact that we could have just taken this actually. We already know that this is basically equals to that. So duplicate and cut. So let's do this. Yeah. And we can say the fact that this is proven. Hope that makes sense. So this was proven already. So now we can substitute numbers. We know the fact that KE, right? So KE is 20. So we know the fact that EF squared is equals to 20 because that's KE, right? And we know the fact that GH is equals to 4, right? So therefore, we know the fact that EF squared is equals to 80. So it's equals to 80. So the square root of both sides, so it's going to be the square root of EF squared is equals to square root of 80. So therefore EF is equals to 4 root 5, right? So we know the fact that this is going to be 4 root 5, and also this is going to be 4 root 5. So if we put it back in our diagram, this is going to be 4 root 5, and also this is going to be the whole thing, right? So let me just put it in green. So this whole thing is also going to be 4 root 5. 4 root 5, right? But remember the fact that I said the fact that, okay, we're using that, but to find this one is that we're going to use the parallel lines, right? We're going to use that because we have this full side and we also have this, right? We have this. And if you look at that, that is going back to what? That's going back to the previous question, which is this one, right? Because we need KG, so this one and this one, right? Because we already know what this one is. Hope that makes sense, right? So now we found EF, right? So now in the basically finding, so now we're finding EM, right? So finding EM, right, is that just to keep consistency, what I'm going to do is that we know the fact that it's going to be from this, right? So since it's going to be from this, I'm just going to take this because that's what I need because it has EM, right? So finding EM, so we know the fact that, let me just copy and paste it, taking this, then duplicate it and cut it. And you can say the fact that this is proven. And if we look at it, right, it makes sense. So remember the fact that it's going to be KF, which is going to be, KF is this one, right? Divided by what? Divided by KG, which is this one, is equals to what? Is equals to, which matches up with KF, is going to be KEF, which is this one, right? Divided by this one, which is EM, which is good, right? And we already know the fact that these two are equals to each other, right? That is why we have this one squared. So we already know what is KG is. We know the fact that KG is 16. So it's going to be 16 squared is equals to EM, which is what we're looking for. Then KF, right? So no, I'm sorry about that. We're looking for KG, sorry. So KG, we know the fact that it's 4 root 5. Remember the fact that this is KG, right? 4 root 5 all squared is equals to EM. And we know the fact that KF is this one, which is going to be 16. Right? So this one is going to be 80 is equals to EM. And this is going to be 16. So this is going to be 80 divided by 16 is equals to EM. So therefore EM is basically equals to 5 units.